Alrighty, I think we're ready to get started. Happy Tuesday again. All right, we got a couple things today. So first off, we're going to cover project 1. No, 2. I can count project 2. So we'll look at the solution to that, and then we'll get into chapter 7 here on how we use our classes. This adds a whole other way of looking at problems and solving problems. It kind of expands our tool set out. That's not helpful. All right, there we go. No echoes. That's better. There we go. So we'll cover that, and then we'll talk about project 3, the next one we're going to be working on. Now, I'm open to either option for you folks. Like ideally, it's due before the midterm, and then you have the whole week after this, like we do on 10/19, and then we got the whole week to study for the midterm. So I think that works best. If you feel like that's crazy to just have the 1 week for the midterm, I'm open to making it happen later, but then you have both things out there. So I think sticking to having it due on 10/19 in 2 more weeks is the better way to go for you folks, so it's done and off your plate. And then you can focus on the midterm for 10/26. Again, that'll be open book, open notes, open internet. It's meant to be lower stress. I mean, exams are never stress-free at all. But so I'll give you last semester's midterm. You can look at how I write the questions, what to expect. And then essentially it's, if there was a question about this, I'm going to write another question about that same topic, but just a different question. So you'll know like exactly what's on it and kind of what type of questions to expect. And we'll go over a practice one. So on 10/9, so actually next week then, I'll show you last semester's midterm. So you've got a week to look at it. And then on 10/19, we'll go over the answers to it. So it's a little bit better, again, if you spend a little bit of time trying to puzzle through some of those, rather than me just showing you, hey, this is how it works for the answers. So next week, I'll publish the practice one. The week after that, we'll go over it. We're only hitting a little bit of this chapter 12, just the array list portion. The rest of that you'll save for other classes. So we don't need too much of the collection generics, but we're going to spend a lot of time working with arrays from chapter 11. We'll get into file input and output after the midterm, more about exceptions. So we've talked about exceptions a little bit, at least a try and catch block. We'll get into a little bit more detail on exceptions in chapter 16. We don't need to get super deep. I like covering this for anybody who this is the only programming class they take and then they move on to learn like there are better ways to handle exceptions. But if you do continue on the next course, object-oriented programming with Java, the 2151, I think that's the number, you'll get deeper into exceptions and spend a lot of time there. So we're just going to kind of skim through some of that here. We'll have more time to work on project 4 that night as well. And then come to November 16th, we'll start with Java FX. That's our graphical user interface application. That's how we're going to build out things you can actually click on instead of typing at the console. It gets a whole lot more interesting to actually have something you can interact with rather than just be typing at the screen, which typing is kind of boring. And we'll talk about the final project. I would like people to work in pairs on it, but I know we're kind of still in the midst of a pandemic, so if that's not cool with you, that's fine. You're welcome to do this individually. I think you'll get a better product out of working collaboratively with someone. Right? If you have 2 heads working through a problem and kind of puzzling it out and saying, okay, this is my approach to solving it, this is my idea, you can bounce ideas off of each other and kind of refine it, you'll get a better product at the end. But it does come with a little bit more work because you have to spend the time coordinating and talking with other people and figuring out who's going to do what and how you work together. Git does very well with that, but occasionally is a jerk. So I'll show you a couple of tips and tricks for working with multiple people in Git. Almost every time we can fix something if it goes wrong, almost every time. So it's just a little bit obnoxious occasionally, but we'll talk about it again. And then we're off for Thanksgiving break. The college is off that whole week, which is fantastic. So no class that week. We'll come back. I'll do more stuff about Java FX, just supplemental notes and things, nothing out of the text. So we'll cover all of chapter 17, and then we'll do some additional cool things in Java FX. And then 12.7 is I have no plans to talk about anything. I'll show up here, and if you want to work together with your partner or just by yourself and work with me, I can walk around, help get things moving, get things going so you're not stuck. And then on 12/14, again, I have no plans to talk. It'll be your folks' turn. We'll do a little Zoom session. We won't be here on Twitch. We'll do Zoom. So if you're remote, you can hop in and present your project. If you're here in person, you can just come up front, present your project, and you can show off the little game that we build. This is one of my favorite days because everyone approaches the design of this a little bit differently. And there's not a right way necessarily. Now, if you're really interested in user interfaces and human-computer interaction and that sort of thing, there's a whole specialty field in heuristics and human-computer interaction you can get into. There's actually a master's program out at Dearborn that I'm partially familiar with. I've just seen some of their details. It's a super interesting field and very important. For our purposes, like if it gets the job done, we're okay. Again, that's kind of the goal here. It's your first programming class. If it checks the boxes off, you're good. It doesn't have to be pretty. But you can learn how to make things pretty and usable and more friendly for people continuing on. But everyone's going to do it a little bit different, which is really fun. So you'll see, okay, well, I thought about doing it this way, and they thought about building it this way. And they put their buttons over here. I put my buttons over here. They did text pop-ups. I did just a log of text, anything you want. Right? It comes off a little bit different. So it's really fun. I really enjoy that night. It used to be a pizza party, but unfortunately that is not an option this semester. I apologize. So if you want to come back at some point when life is back to normal, we can do a pizza party. I don't know when that is, but you're welcome to come back and have a pizza party with me at some point. That's it for the rest of the semester. So we're essentially halfway through the content, right? Here sitting in week 6, because we've got, so it's 6 weeks of content. We've got 1, 2, 3, 4, 5, 6 more weeks of content, right? A week of work time, the week for the midterm. That's the only thing I have planned that week. So you'll have plenty of time to do the midterm. I'm not going to try and lecture anything else. I know it might be nice to like do a little bit more content, but then if you finish early, you're just sitting around and it's really boring. Or if I talk first, no one's actually listening because they're still cramming for the midterm. I found that just doesn't work. So you'll just spend the whole week there on the midterm. Right. Thoughts, questions, concerns? I know scores. I've got your project 1s graded. Apologies for the delay. Almost everyone did super well on it. Really happy to see everyone be very successful. Just a couple issues here or there. A couple of people tried to use math.round for actual rounding, and remember that doesn't work because then you're not going to have enough food, right? You had to use the seal to round up. A couple of people did a fun approach. They said, hey, I'm going to do the integer division and I'm going to do the double division, and if they don't match, add 1 to the integer division. That was neat. I actually hadn't thought of doing it like that. One person used modulus, which is another way. So if there's no remainder, great, we're fine. If there's a remainder, add 1 to the integer division result, and that way you don't have to use the math seal. Any of those approaches are fine, right? As long as you are properly rounding up was cool. And that's the fun thing, right? There's lots of different ways to use the tools that we have to do these things. All right, so let me close these projects down, and I'll start up a new project for project 2. Java with Ant, Java application. Make sure it's in my 1500 folder. So the project 2, I'm going to call this one the evening one. The morning class has a different project to the new folks, which is all sorts of fun. If you're bored and want more projects, you can do theirs too, just if you want more practice. I was talking with one of my colleagues, and he says that his students over at Auburn Hills say there's not enough examples in the book, not enough things to practice and look at. So I suggested they do all of our homework too, and I guess that didn't fly. All right, so again, get rid of some of those comments. Oh, we had the shell of the project, right, already? Should we start with the shell? Because we were going to fill that out. I forgot. Let's do that. Let's open the recent. I think I still got it here. Project 2, the evening shell. Here we go. We'll just fill out the shell of the project. So if you didn't use methods, not a problem, right? You don't have to use the methods to solve this. I like the idea of using methods. Right? Again, it's doing that functional decomposition, taking a big problem, breaking it down into smaller and smaller and smaller and smaller bits, right? I can solve this problem. Right? Problem's a bit of a stretch here, but I can do this task, maybe. Right? I can break it down into small tasks. Do this task, do this task, do this task. Right? And we just keep on going here. Sure, we can do all that. So what do we want to do first? The display story intro? Ooh, Someone on Twitch wants a dad joke before I start. I like that. I collected a couple good ones lately here. So I just recently got a book at the library. They said it was a real popular book. It was about anti-gravity. And, you know, the physics of it are a little bit over my head. I never took enough physics. Actually, I didn't take any physics in college or high school. I went like a different, the tech track, and we didn't do physics. But it turns out it's really impossible to put down. All right, so our story intro then. Sure, so we just print. Welcome to our crappy adventure game. Sure, again, not a very creative writing kind of person. That's why, like, you actually have story writers and things at game companies, not just developers. Not that developers can't be story writers, but it's a different skill set, right? Okay, so we got that. Yep, over at OCC, me Marchy. All right, and then our next one, get users command. Okay, our next method here, get users command. So we don't want to just return nothing here. So we need to go and ask them for some input, right? So we'll use a scanner, we'll call it keyboard, it's a new scanner, and system in, and then we'll ask them, hey, what do you want to do? What do you want to do? Oh, we got to import our scanner, we hadn't imported yet. Yeah, click the little light bulb, yes, import please. Okay, and then we'll get their command, and we can return it. So we can either save it here, like command is keyboard.next line, right, if you want, or you can just say return the keyboard next line. If you like being one line of code shorter, sure. It does the exact same thing. So whatever makes more sense to you is fine. I'll leave it like bigger here and then return the command. Probably a little more familiar to what we've been doing rather than just a straight return. But you might see that, right? If all it's doing is taking something, saving it, and returning it, you can just return it directly. Just a shortcut there. Yeah, definitely. I mean, Mark, can use that title here. Right, so that's our get the command. Right, and then if it doesn't equal the secret escape word, so what should our secret escape word be to get us out of our crappy game? Soup? Okay, soup. All right, we'll try it. Okay, so if the choice, whatever their command was, is not equal to the secret escape word, we're in the loop. Okay, so we'll check if their command choice is a valid command, if that's something we can do. We said, hey, let's return a Boolean true or false. We can do that. Now, this is going to be a little bit repetitive, but I like the idea of this being an if-else here. Right? So we need to check, okay, what were all of our valid commands? We can say, so if choice.equals ignoring case, if it equals, what do we say, like north, we can return true. That's a valid command. Right? Fine. And then if it equals east, it's a valid command. If it equals south, it's a valid command. If it equals west, it's a valid command. And then we need action. So we had our 4 directions, and we need some actions. 1, 2, 3, 4 actions. Right? So what do you think for actions? Did you have like run or something? Or jump, run, jump? How about hide? Swim? I don't know. That probably doesn't make a lot of sense for a swim command. It doesn't have to make sense. It's a crappy game. What else do we have? Sleep? Yeah, so if you included sleep in one of your 4, I think that's fine. I don't recall if I asked for that one to be separate or not. I should double check. If that counted as one of, I think it counted as one of our 4, right? Let's edit that. Let's see. So check the rubric, right? Because that's how we're going to get the points. We get the intro, 4 possible directions, using the sleep command. Okay, so 4 actions. Sure, I guess sleep counts as that. That'll do. So sleep was fine. So there's north, east, south, west, run, jump, hide, sleep. If we haven't returned true in one of those, right, we'll return false. It's not valid. Right? So that's our list of commands. If it's not in here, it's false. It's not a valid command. So you don't necessarily have to have all these return trues either. We could do a bunch of ors if you want. This is going to work out a little bit easier for us to copy paste in a second. I like this being a bunch of different ifs rather than if this or this or this or this or this or this. It could just be one big or. Sure, that's fine. And then it might actually be a little bit cleaner then, because then you can just return the result of that. A lot of times people would do something like, hey, if choice equals in your case equals true, return true. Right? If you're comparing yourself to true, you already are a true or false value. Right? You've gained nothing by saying, if I'm true, do this. Because this already is, if it's true, we'll do this. You don't have to say, if true equals true, do something. You're going to say, if that thing is true. You'll see that a lot. But okay, cool. So now we've got is a valid command. If it's not a valid command, we have to tell them, you can't do that. You can't do that. Okay? Yeah, Mike, it's easy to overcomplicate. No big deal. It's not a problem. Like, as long as we're getting the job done, that's really what matters. You know, designing it a little bit nicer and friendlier and easier, sure, that's definitely a good thing, but it's not wrong to do it a harder way. Okay, so if it's valid, great, we've got something. We need to include our help command, list all the possible commands, count the number of turns a player plays the game for. Okay, so we can do this part now, right? So we can have a counter for int number of turns. Starts off at 0. If the command was valid, we increase our counter. Right? Is a valid command? Sure. There was a counter. We played the game a turn. Played the game another turn. Played the game another turn. Right? That's why this if is a little bit nice here for us. We can just have a single place to check real quick to see what we're doing. Right? Number of turns plus plus. Cool. So counting the number of turns. If the command is recognized, tell them they can't do that. We did that. Keep the game until they enter the secret escape word. We did that. At the end of the game, congratulate them on getting out. So when the loop is done, right, when this while loop is done, we entered the secret escape word. So we'll congratulate them. You know, thanks for playing our crappy game. And you spent, what? Add in count, number, what do we call it? Number of turns? Number of turns? Playing. Sure. Right, we've got that number we've been counting up. Every time they give me a valid action, we counted it. So this isn't counting the escape word, because the escape word's not in our valid action list. That's okay. Right, we'll just, that doesn't need to count there. If you wanted to add it in, great. But this one's not going to run if it's true anyway. So if they guess it the very first time, if they enter soup, they get out with number of turns. Sure, right? A while loop is not guaranteed to run. So if the very first guess is soup, then sure, they get out. And maybe they'll play again to find out the rest of what they can do. Okay, so get the user's command, great. And then let's build one more method out here. Oh, display help, right? So we can do our help here. So you may, what do we have here? You may enter north, east, south, west, run, jump, sleep, hide, right? Run, jump, hide, sleep. Right, those are our valid commands. Okay. So let's see if the command is recognized, tell them they can't do it. Where was our help one? Include a help command, which lists the possible one. Okay, so maybe help is a valid command, but we don't want to count a turn for that. Right? So maybe we check in here if the choice dot equals ignoring case. If it equals help, then we'll display our help command, display help. Otherwise, we'll do this thing, right? Because asking for help is fine, right? But it shouldn't count towards a turn. Like asking for help is not really a turn. So, okay, if it's not a valid action command, then if it was help, give them help. If not, tell them they can't do that. That make sense? I think in our list of things. Okay, cool. So if it was valid, then how about do action or something? Or do command? Sure. Given the choice. So we'll write another method to actually do the thing that does the part of our story. Or I don't know, display, how about display story for? Story for command, given the choice. How about that? I like that. So we'll display the story. So we need another method. A public static void display story for command, given a string for the choice. Okay. Here's the part that's a little bit repetitive. Right? We need to go and see if they did something. Okay. So there's no returning here, though. We're going to get rid of all these returns. Technically, these are all fine as ifs standalone, because it obviously can't be more than one of these values at a time. A chain of if, else if, else if, else if is slightly more efficient, because if I did enter north, it won't bother looking at the rest of these. So it's not going to spend the computer cycles to check to see if it's true when we know it's going to be false. So else if is better here, but again, you're not really, functionally, we're not gaining anything other than it's a little bit faster. So it's probably better practice here to add in all of our else ifs. We're just going to check, okay, what was their choice? So if they said north, we print you went north towards the forest. Sure. And this one, you went east towards the ocean. And this one, how about you went south towards the plains? Sure. And you went west towards the mountains. Again, story is not great here. All right, if they run, then we tell them you start running from a shadow. I don't know, or you're scared by your shadow. Oh, sure. You jump up and try and catch a cloud. I don't know, hide. You hide from your nightmares. And then sleep. So sleep needs to do something, right? So if we're going to be acting on that health value, right, we've got this static health here that's accessible anywhere in the class. Right, we can modify it here. Great, so health then, let's see, so if we sleep, we'll just say, you take a nice long nap. So what also needs to happen then is their health needs to go up, not +1, needs to be set back to 10. Let's reset it back to 10. Right? If it was north, south, east, or west, their health is supposed to go down by 1. Right? But if their health was at 1 or less, right, we said don't let them do that. So we need a little bit of extra checking. So we'll put it in here, we'll just say health minus minus in each of these here. Take their health down by 1 each time. And then maybe we check. Right? Because it probably shouldn't count as a turn if they try and go north and they can't go north. This is getting a little bit trickier, right? So before we check if it's a valid command, right, we can look at their health. Or if they entered north, instead of just returning true, we can have another check. We can say if health is greater than 1, then we can return true. That's valid. Otherwise, no, they can't. Right? It's invalid. And then it won't count against us here. Won't display any story. Right? But we might not want to tell them you can't do that, or maybe we want to give them a message. Maybe we print here and say you are too tired. I don't know. You are too tired to travel. You need to sleep. Sure, we can give a nice little message here, right? So we have to do this for each of our checks then, for each of our directions. We could do that. So instead of just a return true, right, we'll give them this little message here. Sure. You're too tired to do that. You're too tired to do that. Feeling a little bad, it's repetitive. Well, if we have the same code more than one time, we probably should feel bad about ourselves, right? That's our rule of thumb. Can we do it differently? Yeah, definitely. So we can turn that into our own little method here. Public static. Let's see, if it's going to return something, that should be a Boolean then, right? Because it's going to return a true or false. So we can call this, I don't know, health check before travel. 4? Is there an E there? Why am I not? I don't know how to spell words. Travel. Given a string for choice. Actually, do we even need a string for choice? Right? If we already know it's north, we can just check the health. Right? So sure, we're just going to check health, spit out a message. We don't even need a string for choice. We'll check, hey, if health is greater than 1, return true. Otherwise, spit out this message and return false. Or if our method is going to return a Boolean, we need to return either true or false. So if we had enough health, great, we're good. We don't need to spit anything out. If we don't have enough health, we'll tell them you're too tired to travel. They should sleep. And then return false. So in each of our checks here then, for north, east, south, and west, they're surprisingly hard to say. Don't know why. For each of our checks then, we can just ask for the health check. And because this returns a Boolean value, we can say return the health check. Because doing the health check will give me back a true or false. I can just give you back that true or false. If you had enough health, great, it's valid. If you didn't have enough health, you get the message and it's invalid. That makes sense? So we can have that same chunk of code all these places with the method. It's one of the things we can do, right? It's repeated code, so we can turn it into a method. Okay, so if we got to the display story, all we need to do is take the health away, because we know we already checked for it. All this is doing is displaying the story for it. Right? We checked if it's valid, was checking to see if we were able to do it, if we had enough health to do it. We got help. We got, why is that one? This if statement is redundant. Yeah, we could, okay, because we can combine it. That's fine. Here's all of our actions. Right? Display story, north, south, east, west, run, jump, hide, sleep. Feel all right? I think we've got everything on the list here then, right? Let's take a look again. So we get the initial story, we got northeast, southwest, we got those will reduce health by 1, right? If you do that thing. So where do we have that? If you do that, we'll take your health down by 1, spit out the story. Health down by 1, spit out the story. That one looks good. Cannot use a direction command if their health is 1. So greater than 1, it's fine. Right? If it's not greater than 1, so again, you could have an else here, but it's redundant. If you hit the return, your method stops. It's done. Right? So if this is not true, this will run. If it is true, it stops here, and this doesn't run anyway. So the else is redundant at that point. Yeah, okay, so we're checking, right? If they don't have more than 1, we tell them, no, you can't do that, and you're too tired, you should sleep. Okay, using the sleep command resets their health. Okay, it looks like we put it back to 10, right? You take a nice long nap, and we change their health back to 10. Okay, we've got that. We've got our 4 action commands, hide, fight, jump, sleep. We've got help, prints everything but the secret escape word. We're counting the number of turns. If they can't do that, tell them they can't. If they don't recognize it, tell them they can't do it. Keep them into the game till they enter the escape word. And at the end of the game, congratulate them for getting out. Tell them how many turns they spent playing. I think we've got it all. Should we try it? Okay, let's give it a run. It's a decent amount of code, right? We've got 100 lines or so, 110 lines. That counts all the curly braces too, so. All right, welcome to our crappy adventure game. What do you want to do? What should we do, folks? North. You went north towards the forest. Now what do you want to do? Jump? You jump and try and catch a cloud. Now what do you want to do? East? You went east towards the ocean. That's 3 turns, right? If we're counting. We should try enough directions to make sure we have to sleep at some point, right? We have south for 4, west for 5, north for 6, north for 7, north for 8, north for 9, north for 10. Because we did a jump. Now we should be at 1 health. So if we try north again, you can't do that. You're too tired to travel. Okay, we can still jump. We can still hide. right? Sleep should reset our health, and then we can go north again, right? And then soup should get us out. We spent 14 turns. That sounds about right. So how do you feel? Again, none of this needed the methods, right? We could have, like anywhere we were doing this, could have just been inside this big old loop in here, have all of our if-else's here. You'd have had to do number of turns, a bunch of, like each one of those valid ones would have had number of turns plus plus every time. That's fine. But then you could have done like the story at the same time that you checked if it was valid. So maybe that would have been a little simpler. Not really sure. Oh yeah, we should add it, definitely. We can add a GUI to this. Is that what we should do when we start learning Java FX and do GUIs? That's what me March thinks on Twitch. No, that'd be a very boring game, wouldn't it? But you can have like buttons to click. You don't look excited, I'm sorry. Right, so I think we checked everything off the list. Our main method is relatively small. Right, there's a little bit of stuff in here, right? Not necessarily everything is pulled out into methods, but you can kind of get the gist of it. Right, other questions, thoughts, concerns? So let me get rid of this evening project because we just filled out the shell, right? Delete. Okay, so we pop up GitHub, and I can commit this. So lots of if-else, lots of loops. I mean, actually, not even a lot of loops, right? Just the one loop, really? But it's all happening in the one big loop. All right, so let's see. Don't care about that file. We can discard that one. And we want the shell. There we go. Here's our shell. We don't need the evening file. Maybe I can delete that one. This discard changes, puts it back to the way it was before. This one's a little bit risky to touch if you're picking the wrong things. But here's shell. Okay, so we see it changed, right? We added a bunch of stuff to it. Sure. Took out a couple, like this line changed. It essentially was deleted and re-added with a new thing here. But cool. So here's project 2 done. So how do you folks feel? Did you get it all done? Even if it didn't look the same, that's okay. It doesn't have to look the same. Cool. All right, awesome. So that's out there if you want to take a look at it later. And check it out again. Start up a new project here for, was it chapter 7, right? Classes. Do you folks want to take a break now or after we start talking about chapter 7 for a little bit? I'm open to either. I know it's been not quite 45 minutes, but it's been a little ways. I can do anything. Is that no break? Yes break? All right, so we can start working on chapter 7. All right, we can do that. Easy. All right. So when we talk about classes, the idea here is we're going to start building reusable pieces of code. So we looked at methods and this idea of them being reusable, right? Classes expand that, this idea, and they make code even more reusable. And in addition to that, the same thing with methods, it puts a nice name to what's happening. So like scanner here is a class in the Java library. Java, the fine folks at Java wrote this for us to use, and we just get to use it. That's really handy. It does all sorts of cool things, and we don't need to know how those things work. So the idea is that we're dealing with scanner in sort of this abstract fashion. So one of our key principles of object-oriented programming means that you don't need to know how things work to use them. Right? We're dealing with abstract classes in that, okay, I know scanner says it can get me the next line that you type. Sure, I don't need to know how it works. I don't need to know all the details. So scanner is a little standalone package. It does all the things it knows needs to know how to do, and it gives us public methods that we can interact with. Given system.in, right? So if we type our instance of scanner, right? We're using our scanner, we're calling it keyboard. If I put keyboard dot after my import here, sorry, after we had the import, keyboard dot, I'm going to get the list of, these are all the things it can do. The technical term for this is its API, its application program interface. These are all the things a scanner object knows how to do. We get to interact with all these public methods here, and they will do what it advertises it will do. Right? Again, we don't use a whole lot of it here. Mostly next line is like the most practical for us. Again, the other ones have all sorts of issues. Don't worry too much about it. But it can do other things. Right? The integer class, right? Like integer dot we could parse. Right? That's a method in the integer class. So there's all sorts of classes we've been interacting with. Now we're going to start learning how to write our own classes. So that, again, reusable is a bit of a stretch because we're going to design classes for specific purposes, and we're probably not going to reuse them. But the idea is if it's something and it does a good job of what it does, you can put it out there and other people can use it. There's a tool, it's something about formatting with JSON in Microsoft. And some guy just wrote it and put it out there for free, and he's got almost more than 2 billion downloads of his tool. It's so popular. That's sort of the dream, right? You write a little bit of code that does something, and you can put it out there in the world, and it does amazing stuff. Right? Whether or not you want to make it free, like an open source tool, great. Or if you just want to sell some software, it's cool, right? We can write classes, and they'll be able to do things for us. So when we think about designing classes, usually they represent nouns. So when we think about a big problem, anything that's a noun has potential to be a class. Now, it doesn't necessarily have to be. But in general, classes tend to be nouns. So, like phone is a noun. Right? You probably all have a phone in your pocket or somewhere with you, right? There are ways you can describe a phone. Right? My phone here is, I don't know, 4.5 inches tall. It has so many megapixel camera on the front. It's got way too many cameras on the back, because I don't know why that's a thing now. Someone who knows about phones can tell me, or photography, I'm sure, but like they keep jamming more and more and more cameras on. Sure, so that's a way you can describe it. You might say that's an attribute of it, right? And everybody's phone will have its own set of attributes for that noun, right? If you look outside and find a tree, tree's a noun. Each tree will have its own height, will have its own number of leaves, will have its own bark color, tree color, whether or not it's going to drop nuts, right? Or the little helicopter thing, I don't know. There's different attributes about it. So the noun itself, right, is what the class is going to be, and then the class will have a list of attributes. And then you get the list of things that you can do with it, right? With a phone, you can make a phone call. Not that people do that anymore. Right? You can send a text message. You can use an app. Right? There are actions that you can take. I sort of know what happens when my phone opens an app, but again, you don't need to know the details. Right? You just know, okay, I click on the app, and it opens up, it does the thing it's advertised to do. We don't need to know the details. So we work with the phone in sort of an abstract manner. Right? When you get on a plane, you probably don't know how a plane actually flies and stays in the air. But it does the thing it's advertised to do, right? And there are different kinds of planes. Each plane will have its own set of attributes, right? The model, the make, right? Whether or not it's a Boeing or an Airbus, or other people make planes, I think, but those are generally the big ones, right? Yeah, are noun a person, place, or thing. So when we look at, hey, I need to solve this problem, anything that's a noun has a potential to be a class because we can write code to represent that object like we interact with it in real life. And that's why object-oriented programming is so popular. Because the way that we think about our code can kind of model and go after the way that we work with things in real life. Right? I understand that this is a monitor, but this particular type of monitor has its own set of attributes. Right? So we can reuse, we can have multiple instances of that object at a single time. So really boring classes, and that's okay, because there's nothing wrong with really boring classes, we can write, so in this package level, so it's a little small up there, but you have the project, you have the source packages folder, then you have the package here. We're going to right click and say we want a new Java class. So we're finally going to get to multiple files. Now, Java is very particular about classes, right? You might not have noticed, and I think we talked about it like in chapter 1, the name of the class has to match the name of the file, letter for letter, case for case. So each file can have one public class. So one file per class, essentially. You'll learn a couple ways to break that rule in the next class. But we can do, how about a rectangle? So rectangle's a noun, right? And you can have all sorts of different kinds of rectangles. So I get package, right? And then I get public class rectangle. Notice there's no public static void main string args. Right? This class is not meant to be run directly. We're going to use this class in our code here in our chapter 7 classes Java in our main method to do something with rectangles. Right? So we can ask the user, so enter the length rectangle you want, and then we'll get an int for length is integer.parseInt of the keyboard.next line. Great, and then we'll repeat that for width. Enter the width, and int for width. Great, so now I have a length and width. Now I need to make a rectangle. All right, so over in our class now, we've got a couple things. We're going to have a list of attributes, and then we're going to have a bunch of methods. Different people have different ideas around what should go first. Some people say put the attributes at the top. Some people say put them at the bottom. I don't care. It really doesn't matter. Just pick one and stick with it. So if we know rectangle, and we know rectangle is going to have attributes, we can list out those attributes. So now there's this idea that as we build classes, you want to give people the least amount of access as possible to your class. Right? They should have access to call the public methods that do the things you've advertised, but they shouldn't be able to see the internal working details. Right? The idea where it's kind of like the magic behind the curtain. We want to write the class so that they only can do the things we let them do and nothing else. So everything so far we've done, and we wrote all of our project, all of our methods here as public. Public means it's available to anybody. Anybody can see this. So the opposite of public is private. So all of our attributes are going to be private attributes so that no one can actually see them directly. We're going to hide away all those details. So our technical term for that is encapsulation. So when we talk about object-oriented programming, we have abstraction. We get to deal with classes in an abstract manner. We don't know how they work. They just do the things they do. And we deal with encapsulation. We're going to make one nice little package. All the things rectangle go into one little package. The private things stay hidden, and all they can interact with is that public interface. So they kind of go hand in hand with abstraction and encapsulation. We're taking all the details, putting them into one nice little class here. So our attributes, then we're going to say are private int length. So we're saying, hey, I need an integer for length, but hey, this is a private integer. So like in our project, we would say, hey, I need an integer, but actually it's a class level variable. So it's like this one here. We said public static int health. Again, we don't want it to be public. We don't want other people to have access to length. It doesn't matter so much for rectangle, but it's a good habit to get into. We'll talk about more later as we do more examples. But we want it to be private. We don't want other people to be able to access it. So, and it's not static. Again, we'll talk a little bit more about what static means later. But because main is static, we essentially need everything else to be static. We'll talk more in a little bit. So private integer for length. Great, that's it. I've defined it. I'm not giving it a value right now. So all I'm doing is saying, if you have a rectangle, it will have an integer for length. I'm going to have another private int for width. If you have a rectangle, it'll also have a width. So every rectangle that I use is going to store somewhere in memory its length and its width. Right? So I can make 50 different rectangles if I want, and they'll each have their own value for length and width. So they belong to, these are called instance variables. They belong to each instance of the class. So every time I make a rectangle, right, that's an instance of it, an instance of this class. So that's my attributes. I don't really care too much else about rectangle. If we want, we could come up with other things, other attributes about rectangles. We could have like a color if you wanted. Should we have colors for our rectangles? Sure, why not? So we'll say here's a private string for color. So each and every rectangle in my code will have an attribute for color. Right? So I can make red rectangles, I can make blue rectangles, anything I want here. Okay, so now we've got our attributes that now we can start working with these attributes. So we've got our private attributes. Then we need to write the methods that we want people to interact with. So if you want someone to have access to interact with your class, we're going to write public methods. So these are class level variables, instance attributes, and then we're going to have public methods. So you say public, and then we can have methods then that people can access to interact with our code. So some really boring ones are what we're going to start with. So if these are private and we're not letting people touch them, we need to give them public methods to get the values and to set the values. And they're called getters and setters, or accessors and mutators for mutating the values and accessing the values. Anything you want to call them is fine. So we're going to write all the methods that let you get the values and set the values. So we'll do the gets first, because the gets are easy. So public int getLength is a public method then, and we're just going to return the length. So if you want the length of this rectangle, you can call getLength of your rectangle. It'll tell you what the length is. A public int for getWidth returns the width. Notice it lights them up here. So like they start turning green once we start using them. And then a public string for getColor returns the color. So now I've got ways that I can get these values if I have a rectangle. And we also need ways to set the values. Now set methods are great because the object, the class itself, should make sure that it's in a good state. So we can write a public method. Now set methods are typically void. Like they don't return anything. They're just going to set the value. So we're going to say public void set length. And to set the length, you need to give me an integer value for length. Now notice this length is orange. Right? When we did our methods, anything that was a method argument showed up in orange here. Our class level attributes are showing up here in green. And your colors might be different if you didn't turn on dark mode. But it colors them differently. So set length, given a length. So I'm going to take my length and set it equal to this length. Now the problem with me having an attribute called length and the argument being called length is they have the same name. So if I say length equals length, you notice they're both orange. So it's saying, hey, this orange length, set it to the orange length. And it's even telling me, oh, it's assignment to itself. This little, okay, you did a silly thing here. So how I say I want my instance attribute length, I use a keyword. I say this dot. So this means my current rectangle, the instance of the rectangle that's being called on. So this dot length is the green length, the instance class level attribute, and the orange is the argument here. So say, okay, my length equals the length you give me. Great. So we can set the value for it. Okay, and I can do the same for set width, given an integer for width. So this dot width is the green, the class level equals the width argument here. Great. And then one more for color. Void set color, given a string for color. This dot color equals the color. Okay, so again, if you're seeing orange and orange or whatever the same color is, something went wrong here. Now, the names don't have to match. You could say like L. I don't like that. Again, variable names should be nice and descriptive. Some people think this is too tedious to write out. I don't. But so some people say always use a different name here. Sure. If that's what you want to do, go for it. But again, length is always better than L. Right? Width is always better than W. So now we've got a class here for rectangle. We can set and get all of these. So in our code here, that with the main method that's going to run, I can make a rectangle. Remember, when we want a new something, we have to say, hey, here's the type. Like a scanner, I'm going to call it keyboard. An integer, I'm going to call it length. It's a type of rectangle. Rectangle. I'm going to call it my rectangle. Okay, so I'm telling Java, hey, I want to use one of these things here. I'm going to call it my rectangle. Now we have to create it. So we've declared it. Now we need to instantiate it. When you're working with classes and making an instance of the class, like we're going to load that class into memory, we use the new keyword. Okay, so this makes a new scanner, load scanner in memory pointed at the system input. So we're going to make a new rectangle. And then you get a set of curly parentheses. Rectangle, can't spell. A set of curly braces, parentheses. Technically, we're calling a constructor here. We'll talk about those in a little bit. Hey, thanks for coming along, Rock and Hermit. Good to see you. So now I've got this thing I'm calling my rectangle. It's an instance of rectangle. Right? This new keyword says, hey, load one of these things in memory for me. Java's going to go ask the operating system for a place to store an int for length, an int for width, and a string for color. It's now reserved some space. Now I can use my rectangle to call a bunch of methods. So notice if we just do rectangle and say dot, there's nothing here. Right? There's nothing the rectangle class itself can do. But if you have a rectangle, if you have an instance of a rectangle, we've created an object that is a rectangle. Now my rectangle can do dot, and we get a bunch of stuff. Now there's things in here that we didn't write. ToString, waits, notifies, hash codes, get class equals. Don't worry about those for now. When we talk about inheritance next week, they'll make a little bit more sense, but for now, just ignore them. Just look at the things that are bold. Get color, get length, get width, set color, set length, set width. Now, notice it also says like set color is string for color. If I come back to my class here, and I say set color is giving me a string called C, and my this color equals C, perfectly legitimate code, nothing wrong with it, except for the variable name is ugly. If I come to my rectangle and I put dot here, when it gets to set color, like the helper text here just says string C. Now you could probably guess C means color, but again, using a good variable name is going to show up when people use your class. That's why good variable names, good argument names here, parameter names here are super important. Okay, so I'm going to undo that. I want color, semicolon, there we go. I want color back. So we need to call these set methods. So we're going to say, okay, I want to set the length to this length that I just asked the user for. Great, now it will set the length value of my rectangle here. I can do my rectangle and I can say set width, given the width. Okay, it'll set that, my rectangle instance width here. Oh, I need to ask for a color too, right? So what color rectangle do you want? And have a string for color is just keyboard.nextLine. Whatever they type in, we're going to assume it's a color, hopefully. And then we can call set color, my rectangle dot set color, given the color. Okay? Again, not super interesting. We've just set a bunch of values, and then we could get them back out if we wanted. Right? We haven't really done a whole lot. There's no real functionality here, other than it stores values. Sure, but now rectangle can do other things. Right? If you know what a rectangle length and width is, you could probably calculate the area. And I'll think it back to geometry class, right? So we're going to add another method. We're going to have a public int. This method's going to return an integer. It's going to be called getArea. So we'll have an int for area is the length times the width. And then we can return the area we just calculated. So we can add more functionality now. So it's not here's setting an attribute, here's a set and get for it. It will, for any given rectangle with the length and width, will tell you what its area is. Sure, I know that's easy, right? But we're starting off with a nice small example here. So then I can say, okay, so we'll have an int for area is my rectangle dot get area. Right? This method will return a value. I'm going to save it as area, and then we can print it out. We can say your rectangles area is plus area. Okay, so now the class rectangle that we wrote can do this operation, can do all the arithmetic. We don't need to do it again in our class that has the main method that's running. So we give this a run. Again, it's going to find the method main and start at main. Right, what length rectangle do we want? 7? All right, what width rectangle do we want? 4. And what color should it be? Purple. So the rectangle area is 28. Right? 7 times 4. It doesn't sound super interesting yet, but now we can do it again. We can make another rectangle if we wanted. Right? Let's let's make another one. Here, I'm going to copy all of these here. Why not? We'll do it one more time. Now I don't need to tell Java their new values. Now I'm going to make another one here though. This will be, instead of my rectangle, I'll do another rectangle. Use a new rectangle. And then I'm going to use another rectangle on each of these. Area, your other rectangle area is. So it's the same prompts, again, not anything interesting with the prompts here, but when we use this line here to make a new rectangle, now Java has 2 different rectangles in memory. It's storing 2 different instances of the rectangle class. Each one has its own length and width and color that's separate from the other one. Now, that we could give them the exact same values, and we're going to have the exact same values twice in memory. But we can give it different values. We're still going to have that first rectangle with whatever length and width and color it had, and then the second rectangle will have its own length, width, and color. So we can use as many of these as we want here. Again, rectangle's kind of boring here, but we can get to some more interesting classes after we get some basics. So we run it now. Oh, actually, here, instead of run, let's do this in debug mode. So let me stop this, because I want to show you how we can see this happening. So, and debug mode is really fun here. So I'm going to put the breakpoint at line 19. Okay? And I'm going to run with debug mode. Let's check our output window here. This one, right? Okay, what length? So we did 7 and 4. And what color? Purple. Okay, now we got to line 18. So you can see there's variables here. I've got a length, I've got a width, I've got a color here. I've got all those. I'm going to step over. Now I also have a myRectangle variable, which is a type of rectangle. Sorry, this is coming out a little small here. Now, it's got a little arrow to expand here. So if I expand my rectangle, I can see the attributes of this rectangle. The myRectangle are length, width, and color. Right now it's 0, 0, and null. Null's really nasty. We'll talk more about that later. It's ugly and in trouble, but that's okay. Now, if I want to, I can use step in. So to step in means, okay, go into what's happening here. So I'm about to run set length. I'm going to step in. Everything changes. I lost all the other variables because what's happening now is I'm inside the rectangle class. The only thing I have is an argument for length. So I see length is 7. And then I have this. This is the current rectangle we're looking at. So this now has a length of 0, a width of 0, and a color of null. We run length. This length equals length. And now this length is set to 7. Great. So we can see the set method running, and we can see all the values of the current rectangle that we called. And we step, and now we're back to set width. We come back to where we were. Right? I still have my argument, my values here for length, width, and color, but now my rectangle, if I expand that one open again, it now has a length of 7. We've set using 7. Right? We'll do set width. We don't have to step into if we don't want, and we'll see this width now changes to 4. We set color. This color now changes to purple. Right? So this instance, the my rectangle instance, has a bunch of values now. We've set them. Yeah, Apollo. Yeah, it's going to automatically clean up when you're done using the object. If it goes out of scope, it gets cleaned up, is the technical term for that. All right, so now we're going to get area. So if we want, we can step in again. Right, so step in will take you to the getArea method in the rectangle class. Now we can see this, again, here's a 7 by 4. So it'll calculate area. Area is 28, and it returns area. Great, now we've got an area for use in the main method. All right, we print out the area. Do another length and width. So back in our output here, right? Let's do a different one. How about 20 for length? And get a width. Back to output. I'll say maybe 15, sure. And we'll get a color. Back to output. It's a little bit obnoxious, sorry, to go through all these steps. All right, how about this one is red? All right, so now we're about to make a rectangle. Right, so we make the rectangle. Now we can see I've got a my rectangle and I have another rectangle. So as soon as we've made it, it now has length of 0, width of 0, color of null. And we call these set methods. When I step in, I'm back to, they're all empty because I'm working on the another rectangle instance, not the my rectangle instance that already had values. We can step and see, okay, we're going to set the length. These ones get set. So now another rectangle has int length of 20, int length of 15, color of red, and my rectangle, the first one, was 7, 4, and purple. These are all out in memory somewhere for Java to use. So we make an instance of the class, and we can then go use any of the public methods that it has. Again, they're not the most interesting methods right now, but that's okay. We let it finish, so that area was 300, right? 20 by 15, I think the math checks out. Turns out Java's halfway decent at math. So we're writing a class that we can then make instances of. As many rectangles as I want in memory, I can make a bunch of rectangles. Now, rectangles not all that interesting. We'll do maybe a slightly more interesting example after break. We'll try another class here. So one more thing about classes before we take a break. We want to look at how you can show a picture of a class. Right? We're all about pictures, and this idea of the UML, or Unified Modeling Language, is a universal standard for how we would draw pictures or document the things that we're building here. So what you do is you draw a rectangle here, and you put 3 sections. The top section is the name of the class. The middle section is going to have all of the attributes, right? Now, UML is funny. It's backwards. So instead of saying integer for length, I say length colon integer. I don't know who decided it. I didn't get a pick. And I have width colon integer. I have color colon string. Okay, all the attributes go in the middle. Now, additionally, there's some cool notation with UML. If something is private, you put a dash in front of it. If it's public, you'll put a plus. So that's all of the attributes. And then we do the third section. So this is actually, needs to be a little bit bigger here, because we have the third section is all of the methods. So we'd have get width returns an integer, so colon int. It's the return type. We'd have get length returns an integer, right? So again, drawing this out by hand is a little bit obnoxious, so I'm fond of Word. There's better tools than Word, but I think Word does a decent job of this. I'm going to insert a table, and I want a 3x1 table. I'm going to say rectangle here. Again, if you want to center it, that's proper. I don't really care too much. And then we're going to have a width or length, right, as an int. Nope, not capital, please. Length as an int. We'll have width as an int, and we'll have color as a string. Okay, this turns out a lot prettier now. And then for the methods, again, plus for public. Yeah, just a visual representation of what we did. Yeah, it's not a technical drawing. It's not a diagram. I mean, you put these things together in fancy diagrams in UML, but this is just a picture of the class we're going to build. So plus is for public. So I'm going to have a get length method, returns a type of integer. I'm going to have a get width method, returns a type of integer. A get color method returns a string. Right, so those are the gets. Now the sets. So I have a set length. Now again, we do it backwards. So we need the parameters or arguments that we need. So I need a length as an integer, and then it's void, right? It doesn't return anything. So set width, given a width as an integer, again as a void method. It helps if you could spell width, DTH, oh my goodness, and a set color, given a color string type, and it's void, it doesn't return anything. And then our get area returns a type of int. Right, so those are all the public methods. So depending on what tool you use to draw this stuff, again, Word obviously doesn't, because it's just a Word tool. There's some fancy software packages you can get that if you can draw a picture, it will write the code for you, which is really cool. So like sets and get methods are relatively basic. It knows how to write them for you. It's really smart. So depending on the tool you use, again, you can learn all about all sorts of fun tools in the software engineering class. But drawing a picture here is fantastic because I can show this to other developers and say, hey, this is what I'm thinking about for a class. And they don't have to look at any code. They say, okay, abstractly, I can see, here's all your methods. These are the things I would interact with in your class. Now, again, we're exposing some details. Great, I'm going to show you all the private variables I have. No problem. Again, this is a design document used for communication with developers. Great, we can see it. So it gives us a nice picture of what the class is and what it's going to do here with UML. All right, so then we had our basic class. We've got our variables. A hat. Oh, I forgot to bring my hat. I'm sorry, Jacob. I had it on earlier today. I'll have to redeem those points for you. All right, so that's our UML picture. Why don't we take a break? And we'll come back. We'll do a different class example, something maybe a little bit more practical that might make a little more sense for using, but it'll be a little bit more interesting. All right, so when we take 10, I think I can put some music on for you folks online, and we'll go from there. Don't think the music, I thought it came through at one point in class, but now I'm not hearing anything. Oh, you can kind of hear some beeps. That's super quiet, sorry. Just do some chill music. All right, so we'll come back in 10. Break time. Put that at, what does that put us at, 7:23? And we'll go from there. Alrighty, I think we're back here. All right, so we're going to look at a different example here that hopefully will be a little bit, I don't know, make more sense maybe. A little easier to understand, I think. So rectangle is very basic, doesn't do a whole lot. One other thing we could do real quick before we're done is in the set method, right? This idea that a class represents the object and we've encapsulated all the details together and you get to interact with the public interface, all the public methods, is great. But a class should also be responsible for making sure it has integrity. And that means if a rectangle can't have a negative length, it shouldn't let you give it a negative length. So in this method here, instead of just taking the length you give me, because you could give me a negative integer, that's a valid integer, I'm going to check. I'm going to say, hey, if the length is greater than 0, then I'll take your length. Otherwise, right, else we'll set this length, I don't know, I'll just leave it at 0, like otherwise. I don't really know. Oops, too many curly braces, sorry. So if the value is valid, great. If it's not, then I'm just going to leave it at 0 and it's bad. It was no good here. So a class should make sure, and can do that in these methods, that you're only giving me valid values. Right? Same with set width. So we'll say if the width is greater than 0, great, go ahead and set it. Otherwise, we'll set this width to 0. Now again, be careful using this width because you have the width argument here. Be a little careful with that. Okay? So we can do some sanity checking. And we're going to do more of this with our next example. But this is something a class is supposed to do. Right? Make sure that you don't put me in a bad state. So again, 0 is probably okay. I mean, can you have a one-dimensional rectangle? I don't know. Maybe we could say like at least 1. I don't know. Or not set it to 0, but that's probably fine. Unless you tell me a value, I'll leave it at 0. Okay, so we fixed up rectangles. So let's do another class. So imagine we're trying to write an application that is going to let a bank track the money for people that have deposits there. Right? So we'll have lots of people. People can have accounts. So we'll have lots of accounts on file. Right? An account will probably belong to each person. We'll know who owns the account. And then, with these new reporting procedures that have to go in place, any transaction over $600 will report to the IRS to make sure people pay their taxes. All that good stuff in the news. All right, so we can write a class then that represents a bank account. That's a noun, right? That's a thing, the bank account. Each bank account knows who owns it, right? It has its current balance, and it has ways to interact with it. You can put money in a bank account, and you can take money out of a bank account, right? You can deposit and withdraw. Right, so as we're just thinking about a bank account, we can start kind of designing a class for it. So let's do the picture first. Right, the picture really is worth 1,000 words. So if we have a bank account class, we said it has an owner, right? Owner, which is probably a string. Again, in real life, we'd have all sorts of details about the owner. We're going to cheat on it and just you tell me who owns it. We'll take it as a string. You don't need their social security number. You don't need their driver's license number. All that nonsense of a real bank. We're a pretend bank, okay? Maybe an offshore bank. And we're going to have a balance, probably as a double, right? Because you care about the pennies in your bank account, right? Those do matter. If they start just taking away your pennies, most people would be a little bit upset. Not that you can do a whole lot with the penny nowadays, but just it'd be unfair. So we have an owner and a balance as attributes. That's probably it for right now. I mean, we could add other things later, maybe. Or do you ever earn interest on your bank accounts? Is that still a thing? Like they give you money for leaving money deposited at the bank and then earns interest? I know the rates are terrible, but does anybody get interest on their bank? No? No, that's really depressing. I mean, it's like less than a percent, so it's not a whole lot of money, but let's say that for anyway. So we'll have an interest rate. Interest rate probably has a double again. So we'll let people earn a couple pennies for their deposits here. We'll be a nice, generous bank. Okay? So we'll have a couple things. So public methods then, right? Again, all the get methods, all the set methods, those are boring, right? Now, here's an interesting thing. Just because we have a value for balance does not mean we need to let you use a set method. You don't have to write a set balance method, right? People don't go to the bank and say, this is my balance, right? That's not how you interact with the bank account, right? You put money in and you take money out. So we don't have a set balance method. You could probably have a set owner and change who owns the bank account, but you would probably just close the account and have a new person open one. But again, sure. So like set methods are not required here. So just because you have an attribute doesn't mean you need to let people change it. Okay, that's just keep that in mind. Now for interest rate, yeah, this will probably change as the interest rates change. Right? We're not going to guarantee it will stay the same forever. So having a set interest rate makes sense. And that's something we can set. I mean, we probably wouldn't let people do, but our bank would need to manage that. And the bank would say, okay, here, let's go set the interest rate. So for get, then we'd have a get owner as a string. We'd have a get balance as a double. We'd have a get interest rate as a double. And then for set, right, sure, we'll have a set owner given a owner string. And Coke burps inside a mask are awful. That's void. Set methods are usually void. We don't want to set balance. We want to set interest rate. So set interest rate given a interest rate again as a double, right? And that's void. Okay, cool. Now the other methods and how we interact with it, right? We're going to have a deposit given a, I don't know, amount as a double, and that's not going to return anything. And then we're going to have a withdraw method, withdraw an amount as a double. Now this one probably should return something, right? So if you go up to your bank account and say, I want to take $10,000 out, they're going to tell you no, most likely, unless you folks have a lot of money in your bank account, right? So you get something back, right? You either, yes, I'll give you the money, or no, you don't have that much money. So this probably makes sense to return a Boolean, right? Like, okay, yes, here, yes, it worked, or no, it didn't. That sort of thing, right? If you try it at the ATM, it says yes or no. I mean, if it says yes, it gives you the money too, but at least you're going to get this response out. So we'll have this withdraw and deposit way of interacting. Okay, so that's our bank account class, essentially. Okay, so we're going to make a new Java class, and every class gets its own file. So we're going to have a class for bank account. Take out all this garbage, and then all of our attributes, again, our class level private attributes, they're instance level attributes. So every instance of bank account will get its own value here. There are differences, and we'll look at some of those later, different ways of doing this, but for now this is easy. We're going to say, hey, a private string for owner, a private double for balance, and a private double for interest rate. Okay, those were our values. Then some methods. So public get owner, right, returns the owner. Public string get owner. Public double get balance. Public, oh my goodness, public double get balance. Returns the balance. A public double get interest rate. Returns the interest rate. Oh, we forgot one other method, right? One other, oops, that's not a, one other thing that should happen, right, is you should earn interest. Interest, right? When you earn interest, like you get whatever our interest rate is of our balance added to our account, right? So if you let money sit in the bank, they're supposed to pay you pennies for having it deposited there. So we'll have one more method there, so we can show that. And those are the gets, right? We're going to have a void for set owner, given a string for owner. We'll say this dot owner equals the owner, and setting the instance attribute to the argument here. And then we'll have a public void set interest rate, given a double for interest rate. So this dot interest rate equals the interest rate. Okay, so we got those, and then we're going to have the deposit and withdraw. So deposit, right, was void. They will always take your money, right? They're never going to tell you no, right? I guess unless you're depositing counterfeit money, then they might tell you no, but that's another story. We can't check for that in code. So double amount to deposit. Great. So to deposit, we're going to take the balance, plus equals the amount. Now, you might also want to do a little bit of sanity checking here again, because users will do the weirdest things to you. And I mean, ideally, like this software is probably going to be run by our teller, who probably knows a thing or two. But just to be sure, if I give you a negative amount to deposit, I'm actually taking money away from your balance. So we probably shouldn't do that. So let's just do a quick little sanity check. We're going to say, hey, if the amount is greater than 0, then let's go do the thing, please. Right? If it's not greater than 0, let's not do the thing. Right? Don't deposit negative money. Right? Technically, go get a loan, right? I guess it's depositing negative money, because then you owe them more money. Sure. So we're sanity checking our deposit. And then our Boolean for the withdraw here, withdraw given a double amount, we need to do that same kind of checking. We're going to say, hey, if the amount is greater than our balance, we're going to return false. This is no good. I'm telling you no, game over. You can't take out $10,000 if you don't have $10,000 on account. Okay? Again, else is redundant here, because if we hit the return, the method's done. Nothing else shows up. Right? So we don't need an else. We're just going to continue. If this is not true, then we'll take our balance minus equals the amount, right? Subtract it from the amount. And again, we probably also want to check that this is a positive number, because if they give me a negative number to withdraw, they're now adding to their balance, right? If you subtract the negative, you're adding. Think back to math class. So we can do another sanity check. We can check if the account amount is greater than the balance, or the amount is less than 0. Right? We can do this logical operating. So if either one of these is true, return false. Great. It didn't work. Now, we didn't bother telling them it didn't work if they tried to deposit a negative value. Sure. I'm not too concerned here. And maybe it would be fine to do that, but totally up to how we want this to work. So if we didn't return false, we subtracted the amount from the balance, then we can return true. It worked. All right. Withdraw successful. Here's your pretend cash. Okay, so we got deposit, we got withdrawal, and then how about earn interest? Public void earn interest. Interest. So we're supposed to add to our balance, right, the interest rate times our balance. Right? If you get a 1% interest rate, that means you should get 1% of your balance back as interest. But the bank's saying, thanks for depositing money here, so we can go loan it to other people. Right? So we can take our balance, and we can add to it the balance times the interest rate. Right? So like 0.01 will be 1%. Okay? So we'll earn that much interest. Take our balance, add the balance times the interest rate. Okay? So we can now earn some interest on our money. So that's the class. Right? We have public methods, ways of interacting with it, and it has private attributes. Okay, so if we want to use a bank account then, let's put the bank account first here, right? We'll do that on top. Oh, I need that scanner though. We'll put this up top. So we need a string for owner. Is going to be keyboard.next line. We should ask them first, right? Next line. Enter the bank account owner. Okay, great. So now we have an owner. And how about the interest rate? The interest rate for the account. And I'm going to suggest like 0 to, I don't know, 1. Like 1 being 100% interest. No one's going to give you 100% interest. But just like, hey, give me a number between 0 and 1, essentially. Like I want that fractional. So don't enter 3% and the percent sign. We won't be able to handle that. Right? I want 0.03 if it's 3%. Right? So again, just hopefully they're doing the right thing here. This one's a little harder to check. We could do some sort of while loop validation if we wanted, making sure they're giving us a valid number and it's less than 1, or like, hey, if it's more than 1, it'd be like, are you really sure you want 100% interest? Are you this generous of a bank? And if they say yes, sure, we can take it. Again, we've got options here, but for now we'll just assume they enter the right thing. We'll have a double for interest rate. Interest rate is double.parse double of the keyboard.next line. Okay, so now we can make a bank account. So bank account equals a new bank account. set of parentheses. And it's doing a constructor thing. We'll talk about that next. Now, right, I can do account dot, and I can do all the things. Dot. So we need to set the owner, right, to the owner's name. Great. Account dot set interest rate to the interest rate. Great. If it doesn't do all the type ahead stuff for you, go to your tools and options, and go to editor and code completion. And under the Java language, you want to check these other two boxes. Auto pop-up and subword completion. Make sure those are checked for you. I noticed a couple of people weren't getting the type ahead stuff. It's really obnoxious to type everything by hand, right? You want to be lazy, efficiently lazy. Don't do more work than you need to. Okay, so you got the bank account, and now we should ask them how much money they want to deposit, right? So, how much money you want to deposit? Want to deposit. And we'll get a double for, I don't know, deposit. Double dot parse double of the keyboard.next line. Right, and then we can call account dot deposit, and we can give it the deposit amount. Okay? Cool. So how about we print out, okay, all right, your bank account has, and then let's append in here their balance. So I could write in this line, say account.getBalance. Right? It will go out and get the balance for me. So I do the right things here. I don't need to like save account balance to a new variable called balance and then use that new variable. I can write inside of my print, say, hey, give me the balance, please. Sorry, it's getting a little bit long on that line there, but I'll bump that out one. Feeling bad about it. So right inside here, we'll just go and do that thing. Like if we were to step into in debug mode, it would go into account, find the balance, return it, and it would get put in place of whatever's here. Right? So you don't need to have that line for balance equals this and then just use the balance variable. Okay, great. Now let's earn some interest. It's time to earn some interest. So we'll take account and we'll say earn interest. Great, and then let's print the balance again. Right, we'll see how much they earned. All right, let's try it. So what's the bank account owner? It'll be my bank account. Right, interest rate, like 0.011% is still pretty generous here. So if we put $100 in, we should get 1% of that back in interest, should be $1 back, right? So let's put $100 in. All right, it has 100. It's time to earn some interest. Now our balance is 101. And back to the rectangle stuff. Sure. So now I can have a bank account. Now what's cool though is I can have as many bank accounts as I want. I can have as many owners and people as I want, right? In my code now, I can use this bank account anywhere I need to store this information. Right? I could have a second bank account. Maybe I have a checking and a savings account. Maybe I get better interest on the savings account. Right? Usually checking accounts don't have interest. Is that how no one gets interest on money? That sort of thing. Right? We could open up accounts for people's kids. You could open up multiple accounts. You could have your vacation fund account that you start putting money away to go to Disney. Right? The happiest place on earth. No, they don't pay me to say that. I wish, though. I would totally shill out for Disney. I love that place. So we can use this class then anywhere we want and have as many of them as we want, right? So we might have like Eric's account, might have your account, might have my wife's account, right? My kids' accounts, as many instances of account all in memory at a time. And we could write our code to be a little more complicated. Like, okay, who is using the ATM? Enter your name. Okay, check. Okay, enter your PIN. Go check if their PIN is right. Okay, now which account do you want? Do you want your checkings or your savings? Okay, great. Do you want to deposit or do you want to withdraw? Right, we can add more and more and more to it here, but the account piece itself, we've taken all the details about what a bank account is, encapsulated all those details. We have one nice little class now. Right? And we interact with it in the public methods. It's abstract fashion. I don't need to know how, we wrote it so we know how it works. But if this was in some sort of library somewhere, we would say, oh, okay, sure, I get to deposit, I get to withdraw, I get to set some values. Great, we're all set. Is making sense so far? Cool. All right, so the next thing we do with classes, there's a special method that you write. I mentioned when you say, hey, I want a new one of these, it's called a constructor. It's calling a constructor. The constructor method's job is to construct the object, to make it. to make an object, you need to give values to all of your attributes. Right? That's the goal. You want to give all of your attributes values. We saw when we did this new rectangle and we had color. Color was null. Null is really bad here. Null does all sorts of funky things. So remember, one of the things you can do with strings is like you can get the length of the string here. So if right now I could say, hey, I want a string for my rectangle's color is equal to the myRectangle.getColor. This line of code will be fine, but what it's going to give me back is null. Now, null is a special thing in Java that means it does not exist. It's not empty, it's not blank, it means it's just not there. So if something's null, you can't do anything with it because it doesn't exist. But Java doesn't know that. It's not smart enough to know that it doesn't exist. So if I were to say, hey, the color has blank letters, right? My rectangle's color dot length. Remember, you can use dot length to see how many characters are in a string. We talked about that, right? Does that ring any bells? Take a string and use dot length to see how many letters are in it. Okay, someone's nodding their head. That's good, right? Plus letters. Sure, we could print that. Java doesn't know this will crash real hard in a second. So when we run this here, sure, Eric, 0.031, sure, we got 3 cents back. All right, length of the rectangle, 10, 10. What color? Orange. We get a crash here. You get a null pointer exception. Here at line 51, we can't get string length because my rectangle color is null. It doesn't have a value. If there is no value here, you can't use a method on something that doesn't exist, right? I can't tell you the length of something that's not there. So null pointer exceptions happen if we let things be null. So nulls are really dangerous. We want to avoid that. So what we can do is we can write our own constructor. So when you write a class, Java actually gives one to you. So Java will give you, it's called the default constructor. It sets anything that's a numeric value to 0 and anything that's an object to null. So a string, remember, it's not a primitive type. It's not just a character that stores a numeric value or anything. It stores a reference to something. Right? Here's my string out in memory. It gets set to null because there is no string out in memory. It doesn't point anywhere. So anything that's an object is going to be set to null, which is rough. So we're going to write a constructor to avoid that problem. So to write a constructor, again, you probably want it public. I think you can technically have private constructors, but that's super weird. So just don't. We're going to write public constructors. So public, there's no return type. We just don't say anything at all. You don't put void. You don't put a type. That's how Java knows it's the constructor. And then the name of the method is the name of the class. So I'm going to say public rectangle. Here, this is the constructor method. So name must match the class. No return type. Toop, no return type. Okay, its job is to give values to all of these attributes. That's the constructor's job. How do I make my object? How do I create one of these in memory? So sure, I'll say length is 0. Oh my goodness, 0. With the 0, color is an empty string. Remember, empty is still a string. There's just no characters in it, but it is a string. It is not null. So this avoids the string being null, right? So we wrote a constructor. So now when we run our code, when we get to new rectangle, it's going to run this line of code. If we do the step into, it will step to right here. This is the constructor, right? So here's the name of the class parentheses. Look, we said name of the class parentheses. We're calling a method. It's just the constructor method with that new keyword. So now getColor will return a string. It's just going to be empty, and we'll say it has 0 characters in it. 1 and 1, sure. Okay, well, we got 100% interest. Lucky for us. 10, 10, red. Right, color has 0 letters because we hadn't set it yet. It is there. Now it has a value, but previously, before we called that set method, it didn't have a value. So we can avoid that. So we can do the same thing with bank account, right? Let's write a constructor for bank account. So it's public, name of the class. So in this case, owner is empty here. Balance is 0. and interest rate is 0. Now, the other way you can do this, and I'm going to strongly recommend you don't, but you're going to see people do it, so you need to know that it works, is you can also say, up when you declare the variable, remember like when we did our project here, we said, okay, hey, health equals 10. That's not inside a method. This never runs, right? We never see this run, ever. If we run in debug mode, we have no idea when this happens. Right? You can do the same thing with your instance attributes. I strongly discourage it for lots of reasons. But you can say, hey, owner equals blank here when we declare the instance attribute. And we can say balance equals 0 up here and interest rate equals 0 up here. Don't do that, right? Don't give values when you declare them. Just the reason is it's harder to follow, right? That is supposed to happen in a constructor method. That's where people expect it to happen, okay? So don't give instance values, don't give instance attributes values when you declare them. This is no good. It's just confusing, it's bad form. Again, it works, but it's bad form. So let's try and avoid that. Right? Write a constructor that gives them values. Okay, so I'm actually gonna let me comment this one out here, so like we can see it here, and then I'm gonna not do it because it's already upsetting me. Like, you can do a lot of ugly things with code that work, which is kind of fun sometimes, but it's bad habits. All right. So we've got all of this. Now the other thing is, because the constructor is a method, you can do something with it. So notice, like when we make a scanner, we don't just say new scanner parentheses. We say, hey, system in. You can give the constructor arguments too. So you can write your constructor and say, okay, if you want to make a new one of these, give me an argument. Give me a value, just like any other method. So a bank account, we could say, hey, I'm not going to let you make a bank account if you don't tell me who owns it. That goes against bank policy, right? Banks need to know who owns the money. Otherwise, they're just going to keep it, right? I mean, if you just hand them some money and don't tell them who owns it, someone's going to keep the money, right? And you won't see it again. So we'll say, okay, you can't make a bank account unless you give me a string for owner. If you give me a string for owner, great. And then I can say, okay, this.owner equals the owner. Again, this owner is my instance attribute. The orange owner is the argument owner here. So we're going to make sure you can't make a bank account. So now back in my code here, it's all red and upset with me. It says constructor bank account in class bank account cannot be applied to the given types. Required string found no arguments. So when you write a constructor, it takes away the default constructor. So when we wrote the class without a constructor, right, that was perfectly valid because Java provided us with the default constructor. But when you write a class or write a constructor, it removes the default one. So just because we wrote one here means there's no longer this default constructor. Doesn't work. So I have to give it the owner, which is fine. And then I don't have to call my set owner line here, right? This is now redundant because it's happening in bank account, the constructor here. Again, one more thing that you might want to do. Again, there's nothing wrong with this owner equals owner here, but like if we were also going to take an initial balance, like, hey, if you want to open a bank account with us, you have to put in at least $50 is a pretty common bank rule or something like that. You would want to give them a balance. You don't want to have to redo all of the work of like set to do a call deposit or anything like that to make sure you actually gave me a positive value, right? In case someone like typoed when they're typing this in and they said, oh, they deposited negative $50. You don't want to start your customer off $50 in the hole. That'll just upset people. So we could use the same method. So I can say set owner given the owner, right? These are just methods. Methods can call other methods like we saw last chapter. So my method here can call another method, right? Same with balance. I could call set balance, or I don't have a set balance, but I could call like deposit if I wanted to give an initial balance here. I could do that too, right? We could do all sorts of cool stuff there. How's this part feeling? So we got another class example. We've got constructors now that help us make our objects so we don't get nulls. Nulls are bad. We got methods of interacting here, deposit, withdraw, earn interest. It's going to take some practice. Don't worry. It's definitely going to take some practice. It's a new way of thinking, really. Okay, we've got constructors, we got parameters, we got methods, we got gets, we got sets. Okay, we got objects, we got returning things. Ah, I love this. So NetBeans is really smart. Okay, remember, developers are lazy, and the people who wrote NetBeans are also developers, and they're lazy too. So they put all sorts of shortcuts in here. So let's make one more class here. Let's do, oh, you want to do like phone? Phone's fun, right? So phone has all sorts of attributes, right? So just start like naming off things about phones, and I'll start listing attributes here. String for like what, the make and the model. Is that silly to call it a make and a model? Like you do with a car? I don't know, it's the Apple iPhone string. Yeah, private int number of cameras. Okay. Private. What do we have, like a double for weight, maybe? Sure. What else do we know about phones? Sure, yeah, so double screen height, right? Screen height and a double screen width here. Great. I mean, we could start listing tons and tons and tons of things, right? Your operating system, your, the date you bought it, I don't know, all sorts of things, whether or not you still owe money on it, if it's under warranty, all sorts of fun things. Now, the more attributes you write, you're probably like, oh crap, I have to write a bunch of set and get methods here. I'm just making myself more work. Well, yeah, you are. But NetBeans is really smart. You just come into your class here and right click, and you say insert code. This is like the best button ever in NetBeans. You say insert code. It says, what do you want to insert? It's a bunch of things here. We care about getter and setter so far. So I'm going to say getter. I said, okay, here's all your attributes. What fields do you want to generate your get methods for? I'm going to say all of them. Give me everything. Look at that. I've got a bunch of get methods. Right? They're all called get, name of the attribute. This is a convention we follow. So if you have a class and you want to give access to those attributes, get name of attribute returns that attribute. Fantastic. How about sets? So insert code, go to setter. What things should we set? Well, so now, again, with setters, you don't always have to have a set. Like, once you have a phone and you know what the make and model are, that's probably not going to change. It doesn't make a lot of sense to change make, model, number of cameras, screen height, screen width, weight. I mean, none of these really make sense to set after we've made it. So maybe we don't have a set right now. Maybe we'll add that field for private double get remaining payoff balance or something. Sure, we'll add that. So this one can change, right? If you are paying on your phone every month or something. Sure, we could do that. So maybe we have a set, or maybe we skip it entirely. We can just skip it entirely. We'll pretend like we don't owe money on phones. So no sets is okay. So what we need then is we need a constructor. And says, okay, what values do you need to give the constructor here? I'm going to check them all. I need make, model, I need number of cameras, I need weight, I need screen width, I need screen height. I'm going to generate that, and it does it for me. Now, what a constructor does, if it takes a value and sets an attribute that doesn't have a set method, right? That value essentially is read-only. You're going to set the value once, and you're never going to change it, which makes sense, right? You're not going to change the make model of your phone. Once you have your Apple iPhone 12 or whatever number they're on now, I'm an Android person. I like to make fun of Apple a lot. It's not going to change, right? Not that Android doesn't have its own issues, but sure. So these things are essentially read-only because they don't have set methods. So if that makes sense for your class, great. Right? With bank account, we said you can't just set the balance, right? You're not going to walk up to the bank and say, hey, please set my balance to $10,000. They're going to look at you really funny, right? So you don't have to have sets. So if the value is set in the constructor and never changed again, it's read-only. And you'll actually get these little pop-ups here to say, hey, you can make the field final. I remember we talked about the final attributes when we said, hey, this is like a constant value that's never going to change. We marked it as final. In our code, we set pi as a final value. We did some stuff there. You can use that keyword here. I'm not going to bother with it. That's something, again, you'll probably tackle next class in 2151. where setting it as final makes the rest of your code unable to change it. Just in case you accidentally tried to change make or model, the code itself would say, nope, not allowed to, because you told me this was a final field. Final means set it once, and it's not changeable again. So great, you'll see those suggestions. We're not going to worry about it. Not anything we're going to ask for or expect here. But now we've got a constructor, we've got get methods. Right, so we're going to let the tool do the work for us. So essentially, if you can draw your UML diagram, you can list out all your attributes. You type in all your attributes, and you tell NetBeans, hey, make the code for me, please. It's happy to write it for you. Okay, it's a super helpful trick. You'll generate your methods here. All right, we're going to move on to static things in a minute. And I think kind of want to take a break before we talk about static things. Or are you still fresh enough? We good to keep going? Or do you want a break? Up to you. So probably another 20 minutes or so about static stuff. All right, no one says break. We can keep going. That's fine. All right, so everything we've done so far, we've done with instance attributes. So each instance of phone, or each instance of rectangle, or each instance of bank account has its own set of values. Okay? What we can do is you can write a value to be defined at the class level and only exist one time. So that's called a static value. So for bank account, pretty much everyone gets the same interest rate, right? Now, again, checking account or savings account, those are a little bit different here, but it might just be that everyone gets the same interest rate. This is the, maybe we even call it, hey, this is the savings bank account, savings account here. And all savings account will have the same interest rates across the bank. Okay, let's do that. So I'm going to hit refactor and rename. So to change the name of a class, don't do it by hand, because you'll have to change it everywhere, and then you have to change the name of the file. If you go refactor rename, we call this savings account here. It's going to go change it everywhere. It's going to change it in my constructor, and it's going to change it everywhere I used the account. All these new things here. It's going to change the name of the file. Right? The tool knows how to do this stuff for you, so use the tool. So savings account, great. So we're going to say, instead of interest rate being a private instance attribute, we're going to make it a static class level attribute. So something at the class level, right, belongs to the class. Something as an instance attribute belongs to each instance that you create. Every time you use that new keyword, you're making a new instance. So I'm going to get rid of interest rate here, and I'm going to say private, you know what, let's just make this public. So public static double interest rate here. And let's see, this is, so because it's going to be unchangeable, we'll call it interest rate here. And I'm also going to say it's final. Like we've done these final values before. We'll say it's 0.02. Maybe we're a 2% interest rate bank here. Okay. So now it's a little bit upset. We have to go change some of these things about interest. So we're not going to get the interest rate because it doesn't know what interest. We took away the interest rate value here. So that one's no good. We're not going to set it here because it's final. I'm going to get rid of the set here. I'm going to get rid of the get because it's a public value. Anyone can just go get it here. It doesn't make sense for get. But now when we earn interest, right, we're going to take our balance times the interest rate here. Right, this instant interest rate is going to go find the value that's set as a static value for the class. So now every savings account will have the exact same interest. So it's set one time at the class level, not for each instance of savings account. So static value exists at the class level, not for every instance. So what we're going to get here is that if I have 10,000 customers and 10,000 bank accounts, I don't need to store the interest rate 10,000 times. Now again, sure, that's still relatively small. We're not saving a whole lot of space in memory, but if you don't need to save this exact same number 10,000 times, right, we only need to save it one time, we've saved a lot of space, right? Because it's defined one time in one place. And then say, hey, I want to go change my interest rate. Again, we don't have any methods to do that currently. We can go add some in a minute here. We can change it one place, and all of the accounts will reflect that change. I don't need to change 10,000 customer bank accounts and say, okay, your interest rate is now 2.5%, yours is 2.5%, yours is 2.5%. Right? So if it belongs at the class level, right, at the definition of what a savings account is, we can make it static. Okay, so if we want to add ways to change it now, we can. So if we don't want this to be final, that's fine. Let's start it off at 2%, but then we can add methods to change it. Now, to add methods to change it, they're not going to be instance attributes. You don't need an instance of a bank account to change a static value. Because remember, static is defined at the class. So our methods here then are public static void set interest rate. So if it's a static method, it means it exists at the class level. So you don't need an instance of the class to use this method because it is defined once for the entire class. So if it's a static method, I don't have balance. Balance doesn't exist. It's not there because balance is an instance attribute. It only exists when you have an instance of the class. Right? When we said, hey, account dot, that means this instance of bank account, go do something. Right? I have an instance of bank account here. If I just at the class level have a method for set interest rate, I don't have balance, right? It doesn't exist. It's not a static value. Oh, and we need, that's right, double for interest rate. Interest rate. I can take okay, sorry, it's shouldn't be all uppercase now. So this is just interest rate. Again, back to lowercase, because it's changeable. So we'll say this interest rate equals the interest rate. We'll go change it. Oh, goodness. Non-static variable. It is static. Why is it confused? I think it got confused on me here. Oh, I'm sorry. It's not this. Sorry. There is no this. That's what I did wrong here. Because it doesn't belong to an instance. It's bank account, or I'm sorry, savings account. Savings account dot interest rate equals the interest rate. So because it belongs to the class level and it's a static value, I get at it by the class name. There is no this instance, right? If we're static, there is no instance. Methods, there is no this for instance. Right? So it's the class name dot value here because it's defined once at the class. This will exist only one time. Defined once for the entire class and all instances. So all the instances will share that value. Right? So every bank account we have will have the exact same interest rate because it's set once at the class. So I can set it, and then we'll write a public static double get interest rate. Sorry, this should be private now, right? Because we want to make it so you can't get at it directly. We still want set and get methods here. Return the interest rate. We'll return the interest rate. So again, when we set it, we probably want to do some sanity checking, right? We can say if interest rate is less than 0 or interest rate is more than 1. Maybe? How about we just put it back to 2% or something? I don't know, what that was our default value. Sure. Now we can pick whatever. Maybe you wanted to put it to 0. Your choice. So otherwise, we're good to go. We'll take your value. Okay, again, just doing some sanity checking, making sure we're not going to put ourselves in a bad state. We don't want to give you more than 100% interest. That would be really bad. Right? Or greater than or equal to 1 even, right? Like if someone says 1% and they just give you the number 1, we don't want to double their money every year because our bank would run out of money really fast. Okay, so then in our code, right, nothing, we don't need to set interest rate here. It says, hey, we're accessing a static method, set interest rates. We can say savings account dot set interest rate. So now that we have a static value, if we give it the name of the class and put dot, we see static methods. Right? Like when we did integer dot parse or integer dot. Sorry, if this line doesn't there, we have here integer dot. You get these are all static methods in the integer class. You don't need an instance of integer dot something, right? like integer.parseInt, it doesn't care what a current integer value is. It's going to take a string that you give it and give you a new integer back here. Right? But if I have an integer, like integer my value equals 42, I can say my value, my value dot. Now we get, these are instance values. Notice it's a different list of methods here. I have different values here because this is an instance method. So there's the static class level methods that operate at the class level once for the class. You don't need to have a current one of these in memory to do it. You don't need a current integer to call integer.parseInt. Right? It'll just make one for you. But if you have one, now I can do different things, right? I can get out long values, I can do toString, I can get short values, float values, doubles, all sorts of silly things here with my current integer. So these lists the instance methods, and then integer dot lists the static methods. Right? So class dot will be the static methods. Instance of an object dot, your variable name for an object dot, gives you all the instance methods, the things you can do with this current instance. So account dot will tell me all the things I can do with this account. Account dot. Come on, there we go. Right? I can do all these things with my account. Deposit, earn interest, get balance, get owner, set owner, withdraw. Those are things I can do with my current account. Equilibrium, thank you so much for the reminder to hydrate. I got my Coke right here. I'll grab a sip real quick. It's hard to talk like without drinking for so long. It's super weird. All right. Okay, so our method still works exactly the same, right? This earn interest. Where do we earn our interest here? We deposited, yeah, right here. We earned our interest. It still does the exact same thing for us, right? Because the method here for earn interest just says, okay, give me the class static value for interest rate, multiply by my balance, add to my balance. So the class doesn't care here. And now what we're going to do, when I have my 10,000 bank accounts in memory, I don't need to store 2% 10,000 times. And again, it kind of makes sense that every account would have the same interest rate, or at least the same account type, unless you're going to offer all sorts of crazy perks. Actual business rules and like the ways businesses actually operate with their data is kind of crazy. They have like all sorts of exceptions, and everything is always custom because they want to do things for the customer who pays them lots of money, that sorts of good stuff. But we can imagine it's a nice, hard, fast, clean rule. Everyone gets the 2%. Or if we go change it, then we'll move to like 2.5% or 3% or maybe down to 1%, whatever we want to do. Right? We can change our interest rate. Okay, how's that feel now with static? So we can have static class level variables or attributes. Like so for something like phone, where'd my phone go? There's not really anything all phones have in common that we'd have a class level attribute for. I mean, maybe, what is it, the UMEI ID, but each one has a different number. Like they'll have that attribute, but their values are different. We don't have one attribute that all phones would have the same. Well, that's okay. Pop bottles, they might all have an attribute of being 500 milliliters. It's not even a 20 ounce, it's a 500 milliliter bottle. I didn't even notice that. Right? I don't need every single instance of, hey, this Coke bottle is a different volume. Or maybe you do. Maybe you want 500 milliliter bottles, maybe you want 20 ounce bottles, maybe you want 2 liter bottles. It just depends what we're going to be doing with our data. So there's not necessarily a right and wrong way or a rule that it is always this or it's never this. Right? It kind of comes down to how we want to design it, how it's going to work, what those requirements are for the problem we're trying to solve, whatever task we're trying to accomplish. It'll determine if something should be static at the class level or should be an instance attribute, and every instance gets its own value. We can get static or instance values. All right, so we've got static methods. Now, I said setting values, like when you declare the variable as ugly. Yeah, it is. you can technically have a block for initializing static values if you want, to avoid setting them when you declare them. It's okay. We're not gonna. You don't need to use it. So the book will show you can have these static blocks for things. We won't need to do that. Right. Cool. All right. Next cool thing we can do, or do you want to break now? We talk about static. I guess it didn't take a whole 20 minutes. We can keep going. If you want to break, just shout at me. Right? I'm happy to break anytime. So a cool thing you can do with methods here is that we can make our class be a little bit more friendly. So if you look at, let's see, we were doing a method already, right? Was it when was it? Oh man, I don't remember now. I don't know. We've seen it before somewhere. It's not off the top of my head. If having to give the deposit as a double is sure, that's fine. It can be a double result. But what if we also wanted to say, hey, give me a string value? Right? I just want them to type in a string, and I'll do the conversion for you. We can do that. So we can write another method, public void deposit, with the exact same name, as long as the parameters are different. Here, so I can say a string for amount here. So this is called method overloading. The methods with the same name, different parameters. You can have as many methods with the same name as you want, as long as their parameters are different. And by different, I mean the type is different, not what we're calling it. So I can't say, hey, a string I'm going to call balance, and a string I'm going to call amount. It looks the same to Java. So the parameters need to be different. And that does not include any return types. None of that's looked at. So just the parameters have to be different. So what we can do then is I can try and turn that into a double. Right? Do double.parseDouble of the amount. Right, so we'll get a double for amount or value, I guess. Right? And then I don't want to have to repeat myself. I don't want to do the same thing twice. Methods can call other methods. I'm going to call deposit given the value. Right? I'll call my own method deposit that takes a double here. So all I did is do the conversion. But that way, if someone is using my class savings account and they want to call deposit, right, they don't need to do the double parsing here. Right? They can take account.deposit. Notice now there's two in the list. There's deposit string and deposit double. Either one of those is fine. I can call either one. Right? So I can give it just the string value. I can say, hey, 10, here's a string. It'll convert it to a double for me. So you can add methods that have different parameters. And mostly it's about accessibility, making your method easier to use, or possibly with like some optional arguments. Right? You can have different lengths of arguments here. Let's look at our savings account here. Let's see, deposit. None of those are going to be alternate, are they? Yeah, sorry, none of those have any good methods for extras. Let's see, what do they do? Yeah, that's fine. The object. Yeah, that's fine. Okay. All right. Let's see. I'm trying to think of one that has more than one for us right now. All right, let's go to phone. We'll have some fun with phone. We can pretend to do some stuff here. Right, so we'll do a void method here for like take picture. Because some of you do with your phone is you take a picture. Sure. So we'll have a method for take picture. We're not going to do anything really interesting. How about we just return a string? So we'll say return you took a picture. Sure. Not super interesting. But now let's have another method here, public string take picture. And let's say, hey, give me a string for the mode that you're in. Right? Like you might be in pro mode, or you might be in night mode, or I mean, like there's all sorts of crazy options nowadays, right, for taking a picture. Right? So then we can check, hey, like if mode equals, ignoring case, pro, right, we'll return we took a pro picture. I don't know, something like that. And then if it's not pro, else we'll just return take picture. So okay, we know what pro mode is. I mean, you can add like a night mode, add all the other options here, or just, if we don't know what it is, we'll just say you took a regular picture. That was an invalid mode. So we can have methods then that this essentially is an optional argument, right? If you don't tell me what mode it was, right, I'm going to assume it's a standard picture. If you tell me what mode it is, then great, I can do something with it. So I can have either you give me the argument or you don't. Either one is fine. Right, but if you give me the argument, then I have a chance to do something with that argument. That makes sense? Like we can overload, have more than one version of this, and each one just gives you more options. Right? A common method, let's do one more here. This one's kind of a silly example, but you can have date. Now, dates are actually like one of the hardest things in programming, for lots of reasons. Time zones being one of them, daylight savings time being another. Dates are awful. I hate dates. But we're going to do just a dumb, silly little thing. So we'll have an int for month. We'll have an int for year. We'll have an int for day. Let's go day, month, year, right? And these are all private. A private int, private month, and a private year. Okay? So you can make a date here, given a day, month, and year. So let's write some code, right? We'll go to insert code. I want getters. Great, we'll generate those. Now set is probably fine. I'm going to let you change the date, right? If you want to make a date and then you want to change it, go for it. I don't like there's nothing wrong conceptually with being able to change the month or the day or the year on a date. Great, we'll generate those. Now there's no sanity checking with these, unfortunately. So it doesn't know that, hey, I want to check and make sure it's a valid day. So I'm going to check real quick and say, hey, if day is less than 1, or day is greater than 31. I don't know. What should we set day to? This dot day should be, if you give me something bad, should we just put it at 0? Because we don't know. Sure, we can do that. So like you can't be a -1, and 0 just means, hey, we're in a bad state. We'll do the same thing for month, right? But now that's, what, greater than 12? Year, again, I mean, really could be anything. Maybe just not negative. Unless you want negative to start meaning like BC. Maybe even negative's fine then. I don't know. So year, I think we'll just leave alone. So if you want to come up with the year 2 billion, sure, right? Not a problem here. We got a bunch of sets and gets, right? Now, if we want to make this easy to use and friendly, right, we can add a constructor too. So we can insert code for a constructor that gives you a day, month, and year, right? And again, I don't want to use the this sets. I want to do the set days here. Right, set month, because I already have my sanity checking. I want to do that sanity checking again here with my constructor. And then set year. Okay? So we want to use those set methods because we already wrote the code. I don't want to have to repeat myself. Okay, so we got a date. We can get year, month, and day. And then we're going to write a method for, it's going to return a string for get pretty date. Okay? Now, usually we do month dash day dash year, right? So we're going to return month dash day dash year. Right? We've done these string formats with the substitutions. Have we done that? You didn't do that yet? Okay, I'm sorry. We won't do that then. There's a cool way to make this cleaner, but that's okay. So we'll do, we want the month plus a dash plus the day, the day plus a dash plus the year, right? Month dash day slash year. But then I'm going to write another get pretty date given a string for format. Now, in other countries, it's day dash month dash year, right? So we can say, hey, if the format equals, ignore case, USA, we can return the get pretty date, the default one. Else if the format equals ignore case, I don't know, we'll pick on the UK equals ignore case. We'll say, hey, if you want UK format, then we're going to return its day dash month plus a dash plus the year, right? They do, it would be 5-10-2021, right? They do month, day, year, which is a much more sensible format, right? Going from small to large instead of like middle size, smallest, largest value. But the month, day, year always drives me nuts. And then else here, if we don't know, or maybe we just leave, maybe this one will be our else case here. We'll say, okay, if you want the UK format, else if, then else we'll do this format. Okay, else if my format equals, there's an ISO standard, an International Standards Organization for dates, and they actually do it the proper way, which is year-month-day. And the reason why that's proper is if you go to sort something alphabetically, and it's year-month-day, it will actually sort it properly for you. If you have something in month-day-year and you sort alphabetically, you're going to get all of April for every single year in April, right? And then you're going to get all of May for every single year in May with the sorts. It's going to sort terribly. That's not how you want things to sort, right? If it's year-month-day, it's the right way. And that's actually, I don't know, you can't see my clock online, but here, that's how my clock format is. This is standard. Anytime you work with computer systems, this is the date format, typically, like behind the scenes. So we love that. We love that format. So it's year, a dash, plus month, plus a dash, plus the day. So if you can get different formats here then, right, with this overloaded method, right? So, okay, if you want the UK format, I'll do day, month, year. If you want the ISO format, I'll give you year, month, day. If you don't tell me what you want, or I don't recognize the format, I'll just get you the pretty date. Here, month, day, year. So we can use these overloaded methods, right, to give additional options. So, okay, maybe you want this, maybe you want this, maybe you want this, okay? Now, another crazy thing you can do is you can overload constructors too. So date's fun. We can say, okay, public date, give it an int for day and an int for month. If you don't tell me what year it is, I'll probably assume it's 2021. So we'll set day, given the day, we'll set month, given the month, and then we'll set the year to 2021. Again, this is probably bad form. There's other ways to get dates out of Java. We don't care, right? This is ugly. Don't do this in real life. But you can also then have essentially optional values in your constructor here. So if you don't tell me what it is, I'll give you a default. Okay. Again, this is bad because maybe you're using this code next year, and now everything shows up in the wrong year, right? Like, dates are hard, but they give us some nice examples for, hey, maybe we don't want to have to give all sorts of values. So now I can make dates. I can say, okay, it is the 5th of October, day 5, month 10. Great, it'll fill in the year for me. Or maybe I want to tell it, okay, it's a particular day of a particular year. Great, I can call either constructor here, which is fun. How are you folks feeling? It's a lot. It's a lot. It's a different way of thinking. It's a different way of breaking things apart. But again, what it lets us do is kind of approach things and break them down into a little bit more sensical manner, in that we know what objects are in real life. Right? We work with objects all the time. I understand this is my wrist pad. They don't all have the same attributes, right? You can have multiple of them, right? So we can kind of approach things in more of a human manner, rather than, okay, here's a bunch of code and it has to do a bunch of things. Now I can make an instance of this and I can have it do the things that it's supposed to do, right? If I make my bottle class, I could have a method for fill, and I could have a method for drink, right? The way that you interact with it, it's a little bit more natural feeling. Now it's going to be really funny to write the code until you get used to it, because we haven't done that before. We've just done top to bottom, and then we added branches, and then we added loops, and then we added methods. But again, it was still essentially everything was happening in the one file here. Now we're kind of spreading things out. And again, it's getting further along in that process of functional decomposition. Right? I want to break apart the small pieces and say, okay, well, one small piece is the class for savings account. A piece of that piece then is how do I deposit money? A piece of that piece is how do I withdraw money? A piece of that piece, right? How do I set the interest rate? We just get another tool to break problems down further and further and further. Now, you don't need object-oriented programming to solve problems. It's not required, right? There are languages that are not object-oriented. If you've ever heard of C, the language C is not an object-oriented language. To become object-oriented, they released C++. So C++ is C with object-oriented stuff. It's not required, but it's a style, it's a technique, it's an approach that lets us work with things in more of a human manner. Right? It's a little easier for us to understand things as objects because that's how we deal with stuff in the real world. It's not always just top to bottom. Here's the method or the little routine. Here's the little algorithm. We'll do these steps. Right? So there's a lot to it. Oh, do you feel hungry? Yeah, we didn't even do like the pizza class. That's always a fun one. You know, then you can take bites of your pizza or something, or take a slice of your pizza. I think pizza's nice. Like it knows how many slices it has to start, and then you can like eat a slice, and then it knows, okay, now it has 7 slices, and you can eat a slice, and now it has 6 slices. You can eat a slice that has 5. And when you're out of slices and you ask it to eat a slice, you get really sad. There's no slices left. We'll give you back false. You can't do that sort of thing. We got lots of options. Now, a proper way of writing classes is essentially, you'll notice none of these classes ever do print lines. Right? A class's job is to encapsulate all the details and be self-contained. It has methods that you interact with to do things. If the idea that my code is reusable is that, okay, great, I wrote bank account, or I wrote savings account, now I can go take this and use it in a mobile application. I could take it and use it in a web application. I could take it and use it on a graphical user interface application. None of those show the system out console because you don't run them from the console. So if your class is doing system out print lines, no one's going to see it. It has no idea what's happening or how it's being used. So the only place you do system out print lines is in the class with main. Because you are calling the main method, we know we're running this from the console. Right? This class's job is to do system out print lines and do input here with the scanner object. Classes generally are not responsible for asking the user for input. If you want input, you write a method that takes an argument. Right? If you want to set the owner, the class doesn't say system out print line, enter the owner name, get the owner's name off the console input, and set the owner's name. It just says, you give me the owner's name, and I'll set it. Right? The class should do the things the class does. If you want to ask the user using console input, you do that in your code with main, and then you call the method. Right? That's the way we design it. Because we want this class to be usable anywhere. We don't want the class to be tied to being only usable at the console. Right? So any input and output is essentially happening still in main, or methods in the class main. Now, you might look back to our project 2 and say, hey, all these methods were static. Right? We never have an instance of project 2 evening shell. We never say, hey, project 2 evening shell equals new project 2 evening shell. There's never an instance of the class. When it's loaded into memory, main is a static method. So you can only call static methods in your class. You can't write instance methods. So all of our methods are public static because they're designed to work not with an instance of this class, just here's what it does. Right? And you can use these static class level values. You can access static values from static methods. It's not an instance value. So if I remove the word static, all of this breaks because I don't have health. Right? Non-static variable cannot be referenced from a static context. I think a couple of you reached out and had errors working on the project, and you're getting messages like this. Right? You get that if the value is not static, or you get that if your method is not static. Okay, we can get at health from a non-static method. That's right, but then you can't call that from other ones. So you run into trouble. Well, that's why all of our methods originally were static, because we called them from main where we didn't have an instance of a class. Now that we can write classes, we can write instance methods or non-static methods that apply to the current instance where we have this reference. What is the current bank account you're operating on? right? What is the current rectangle you're operating on? So we can add all those in. Okay. Again, there's a lot to it. It's gonna take some practice, and that's what we're gonna be working on with the next project, is practicing building classes, using classes, writing classes, interacting with our classes, those sorts of things. Okay? All right, do you want to break now, or do you want to talk about the project? I'm open to either. Okay, let's do the project. All right, so let me pull this up here. Back. Discard. I don't think I changed anything yet. We can discard changes. So we need a new assignment here for project 3. Give me 1 second. I got to pull up this on the other computer real quick. Right, so this is project 3. Again, I'd like for this to be due the 19th, so that way you have the whole week after it's due to prep for the midterm. If you feel like that's too much to have the project due and then only a week for midterm prep, I'm open to other ideas, but ideally you get it done and out of the way. All right, so let's add a new score for project 3 in projects category. There we go. So this one will be worth, I think, 15 points. So again, they're going up little by little by little here, because you don't get to forget anything, right? We're still using methods. We're still using loops. We're still using if-else stuff. We're still using all of our data types, that sort of stuff. Let me see here. Yeah, okay, I like that. So we need the GitHub Classroom link. Let me make one of those links for you real quick. So we'll make a new repository, right? Clone the repository, start your project in it. You're off to the races. 1500, 2021, project 3, private repository. With the Java template. That wasn't it. Here we go. Okay, please submit feedback pull request. URL, the self-assessment, the rubric. All right. Oh, no, you know what? I forgot topic. I'm sorry, I forgot to talk about one more thing before we talk about our project. So this one is not in the book, which is unfortunate. I wish they would cover it more. But we're going to talk about how we can test our code to make sure it does what it's supposed to do. Right? So far, like to test our code, we had to go and write a bunch of stuff here in main. And we said, okay, if I do these things, and I deposit money, and then I print out my balance, I'm eyeballing, saying, okay, if I say it's $100 and the interest is 1%, it should be 101. Right? We're going through the process of calling the code, saying this is what I expect to have happen. Did it happen? But the only check that we have is with our eyeballs. Right? We have to look at it and see. And it turns out people are bad at that. Have you ever had to proofread one of your own English papers? Right? We're really bad at finding our errors. Right? Because we know what it's supposed to say, and you kind of gloss over it when you're thinking about it. You can run into issues. So the better way of testing, and we need classes to do this, is called unit tests. So a unit test tests one small piece of code at a time. And we're going to do that exact same thing. We're going to say, okay, I know what's supposed to happen. Let me do the code to make the thing happen, and then let me see if I got back what I expected. Okay, so we're going to do it with savings account. So the fastest way to get to unit tests here in NetBeans, you right-click on the class, you say navigate, go to test. It says, oh, you want to create or update some tests? Yes, please. Leave all the defaults. Now, the one downside here with the Ant projects we're creating, we need to use JUnit 4, which is an older version of testing framework. The newer version is called JUnit. It's not numbered because it's the latest and greatest for lots of reasons. It's actually 5. I don't know why they dropped the number, but it works with JUnit 4. So it's going to default to JUnit. Make sure you pick JUnit 4. And then you want these boxes checked. Don't worry about any of the other boxes over here. We just want these ones here. Okay? It's going to write some tests for us. So we're going to get a bunch of stuff here, and now we get another Java class here that does testing stuff. And we get a bunch of methods, which is cool. So we get, okay, it's test get owner, test get balance, test set owner, test deposit string, test deposit double, test withdraw, test earn interest, test set interest, test get interest rate. So every method that we have, it generated a test method for us. The idea is that we want to test every method that we wrote, because if you wrote code, it's worth making sure you did it right. Right? Any code worth writing is worth testing, because the testing is our process to make sure we're doing it right, aside from, let me put it into a main method, call a bunch of things and eyeball it. Right? We don't trust our eyeballs. We're no good at that. So the computer can test stuff for us. So these are, give this at test annotation. That's a little note to Java to say, hey, this is a special method here. Now, all the get methods are really boring. So I'm actually going to get rid of those. So anything that was a test get, I'm going to get rid of, because we don't really care. The sets are more interesting. Right? Or the like withdraw, deposits, those are more interesting. Earn interest, those are interesting. Because we're actually going to do something. And to test your values, we need to call the get method to get what the value is. So by testing our set method, we're also going to test the get method at the same time. So we're going to test our set owner method and see if it works. So we're going to follow this convention. It's called the AAA convention. We're going to arrange. So we're going to set up all the variables we need to test. And then we're going to act. We're going to call the code we are testing. And then we're going to assert. Sorry. Did we get what we expect? Okay. So to set owner, I need a variable for owner. Right? And I like the format. We're going to say expected owner. Right? Owner. So this is the value I expect to get back out. We're going to say is owner is Eric. Okay. I need to set this up. Great. That's the only thing I need right now. We're not testing a whole lot of stuff. Now we're going to act. So to act, I need a bank account, or a savings account. So savings account equals a new savings account. And I'm going to give it the expected owner, right? We had a constructor here that's being called. Okay. We know that this actually calls the set method. So really, like, we're sort of testing the constructor and the set owner at the same time. So this is the code we're testing, right? And gets the values. So now we need to get the value, the actual value. So we're going to say, okay, what does the account think the owner is? So I'll have a string for the actual owner is my account.getOwner. Okay, so I call the code we're testing. So the constructor here is setting the owner. So that's what we're testing. We want to test that I can set the owner properly. Right? And then we're going to get, okay, what does the account think the owner is? Right? Well, whatever get owner is returning, I'm going to save as the actual owner. Then I'm going to assert that they match. We missed a topic. I'm sorry. I lied. So this is not in the book and how we do unit testing. So we're going to assert. And I can say, now this is assert equal. So assert equals, we're going to say, hey, the expected owner equals the actual owner. So this is everything we would do by hand in a main method. Right? I would make an instance of bank account, give it an owner, get the owner back out, and print it to the screen and say, okay, does it match what I expected? None of this prints to screen, and all of this checking is actually happening in code. The computer is not going to screw up if Eric doesn't come back and it's like ERC and it lost a letter somehow. Again, that's not going to happen, but if it lost a letter somehow, it's not going to say they're the same thing. It's going to know that something bad happened. So we can write a unit test to make the computer do that check for us, so we don't have to eyeball it. So I'm going to right click and I'm going to test file now. And then unit tests are going to run. We get a new window popping up here that we haven't seen before. Open the test result window. It says, okay, my tests passed. Now, it says all 6 passed. It's really tiny, but it has all the method names here, all the test method names. If it doesn't fail, it passes. So it's a little bit risky, okay? In that these other methods don't actually test anything, but they're telling me they passed. So just be careful that if it doesn't fail, it passes. But we'll see that it didn't fail, right? So if I say, okay, instead of the expected owner, if I said test and the actual owner, and I test it again, I run tests, test file. Now I see it fails. Now it's kind of small, I'm sorry, but it says fail. It expected test, but was Eric. So we want to give it in that order when we're testing. We give it the expected value and then the actual value, because that's what it's looking for. And if it doesn't come back right, it's going to tell you, hey, I was supposed to get back test, because that's what you told me. What I actually got back was Eric. And now the test failed. So we can see really quickly that something's wrong with our code without having to write a main method. And we can run this over and over and over, and the computer will always eyeball it correctly, because it's really good at it. So we can write our tests here. So like our deposits then, if we do our AAA format, right, we're going to arrange, we're going to act, we're going to assert. So to arrange, if we make a new account, we deposit some money, right? What do we expect to get back? How much so we need our deposit. So our string for deposit is going to be what like 50 as a string, and then we'll have a double for expected balance. Right, it should be 50. Okay, and then so if I'm using the class, but the constructor is not part of what I'm testing, I'm going to put the constructor in a range. If you want to put the constructor in act, fine, I don't really care, but technically it belongs in a range. So I'm going to say savings account equals a new account, savings account. Now, I don't actually care what the owner's name is. So I'm just going to put an empty string here. Like the owner's name does not matter when I'm testing if deposit works or not. So I don't care what the owner's name is. It doesn't matter anymore. I don't need to give it an expected owner and check if it worked right? I've already tested that unit of code. Now I want to test my deposit code. So in act, then, I'm going to take my account. I'm going to say deposit. I'm going to deposit the deposit string, and then I'll get a double for the actual balance is account.getBalance. And then I can assert, okay, do the expected balance and actual balance match? So assert equals. Now, the problem with expected balance and actual balance is that they are doubles. Remember, Java's really bad at math here. Don't think that's actually going to run. Let me try it real quick. I think it's going to yell at me in a second. When you compare doubles, Java knows it's really bad at math. Yeah, here we go. It says failed. Use assert equals expected, actual, and delta to compare floating point numbers. When you're comparing numbers with decimal places, Java recognizes that it's bad. Like if we've ever went through and like you add 0.01 a bunch of times, eventually like a 10 millionth of a something shows up. I have no idea why. It's just bad at math. So like don't use Java for actual banking stuff, or at least don't use doubles. You have to give it a delta. The delta is how close is close enough. So like as long as they're within like a tenth, hundredth, thousandth, 10,000th, if they're within 1 millionth of each other, I'm going to say we're good. Right? If something happened beyond the millionth of a cent, I don't care. Right? So the delta is how close is close enough. So when we compare deltas, or comparing doubles, the delta that says how close is close enough. Okay? So now we can run our test, and it should pass. Right? It passed. Great. So we were able to give it a string 50. So essentially, I'm going to do the same thing here with our double-based deposit. I'm just not going to use the string here. I'm just going to deposit the expected balance. Same thing, right? If I deposit a 50 using a double, I should still get back 50 for my balance. It passed. Right? We're testing one unit, one line of, or one section of code, one method of code essentially at a time. Right? Test withdraw. So to withdraw, you need to have money in the bank. So withdraw actually has two things that'll happen, right? Withdraw will give us true it worked or false it didn't work. So I need two different tests here, right? Because if I only test that it works and I don't test that it failed, I shouldn't feel confident that it actually does work when I want it to. So this is fails or returns false. How about returns false, right? And test withdrawal returns true. Okay. Nope. So I'm going to essentially copy this again here. But now I'm going to deposit the money in act here, right? Because we're not testing the deposit portion. I'm just setting everything up. I'm arranging it so that it's ready for me to test. Because to withdraw, I need to put money in. Okay, so then I should be able to withdraw. So this one's actually a little bit different here, because if I take money out, I'm going to have a different expected balance. So I'm going to say, hey, my expected balance will be 25 if I start with 50. Right, deposit 50, and I should end up with 25. So when I'm acting, I'm going to test the account.withdraw method. And actually need to save this. This will be my Boolean result, is account.withdraw. If we withdraw 25, right, it should give you back a true or false, because withdraw gives you back a true or false. If I take 25 out of the 50 I put in, my actual balance should be 25. So that one should match. And then I'm also going to test then, I'm going to say assert true the result. That this result, well, the thing I assert true, there we go. Assert true that result is true. It gave me back a true, yes, this was successful. Right? I can do the same thing here for my withdraw returns false. I'm going to say, hey, my expected balance stays at 50 here. Right? If I withdraw 250, I should get back, this will be assert false. And the expected balance and the actual balance should still be 50. Right? If it doesn't work, we shouldn't take any money away. If you only have $50 in there and you try and take 250 away, you should get back a false. Right? We're saying, because I know I wrote the code, and we said, okay, if you tried to withdraw too much, return false. Otherwise, it works, return true. Take away the balance. So we're testing that. Okay, let's give it a shot. So let's run it. All right, it passes. Right? Life is good so far. So then earn interest and set interest. We're going to actually, we'll use set interest when we do the earn interest at the same time. So we need to set up an account, right? Put some money in it. So let's set up an account. We don't need to withdraw anything. We just need to deposit here. Okay, so let's start with 100, and we'll deposit $100 in. Okay, then we want to go and set, because we're testing this, right? We're going to set the interest rate. So savings account dot set interest rate. Let's set the interest rate to 0.01, right? Because we're going to test, does that work? Then we're going to take our account and we're going to earn interest. So 101 is our expected balance. If we start with 100 and we earn 1% interest, we should end up with 101. Right? So we're going to call the earn interest method, and then we're going to get our balance out. See what the balance is. They should match then, right? What I get back out after earning interest should be 101. So again, it's the same stuff we were doing in main, right? We said, okay, let me type something in, let me give it here, and let me spit something back out, and I had to look at it. Did I actually earn 1% interest? Right? We want to avoid all of that work of us having to do it because we can make mistakes. Right? So if I write a unit test, now it is possible I make the same mistake twice. Right? It's possible that I did it wrong in my code and I did it wrong in the test. But generally, if you did something wrong in the code, you're going to catch it when you write your test, because your test is saying, okay, if I do this, this should happen. And if you wrote the code wrong, the this should happen, it doesn't happen right. Right? So we're making sure that our code does what we expect it to do. So we run our tests, and they pass. So there's this idea, when we're writing unit tests, it's called code coverage. The idea is, and there's actually tools that will do this for you. I haven't found a free one for Java. You can buy them, and enterprise organizations that actually write software use these sorts of tools a lot. It will look at the code, and it will look at the tests. And it's going to say, okay, based on what happens in the tests, how many lines of code are actually run in your code that you're testing? And it's a metric called code coverage. How much of your code is covered by unit tests? Right? How much of it actually runs when we're testing? So in our case, if we weren't testing the, okay, we'll return false if your balance was too much. If we only tested that, yes, it works if we give it a good number, we wouldn't have 100% code coverage, because this line of code never ran in our tests. So anytime you have a branch, you have an if, you have an else, you have an if, else if, else if, else if, you need to test each one of those sections to get 100% code coverage. Because otherwise you don't know if it's going to run or not. Right? Or you don't know if it's going to give you the results you expect. So any code that's worth writing is worth testing, making sure it does what it's supposed to do. So we can write our unit tests to make sure, yes, it does. So again, we should probably also test set interest rate to make sure it gets set to 2% if I give it something funky. So right now we don't have 100% code coverage. Right? We're not testing this case for interest rate. We're only saying, okay, it worked. I said 1% here. We don't have 100%, so we need to go back and add another test to get to 100% code coverage. Right, so I'll leave a note right here right now, like there no test currently makes sure this works. Right, I mean, I feel like it should work, but again, just like when you write an English paper, sometimes you typo things. Don't just rely on I think it's going to work. Right, actually try it and see. But instead of having to write a main method that asks for a bunch of values and I put a bunch of values in, it spits values back out, and I have to look at it and say, okay, does that match? A unit test does it in code. We set everything up, we arrange it all, we call the code, get our values back out, and we assert that they match. Okay, so code is really good at this. The other really cool thing that you can do once you have unit tests is there's this lots of tools out there called continuous integration engines. And what they do is they sit there and they look at your Git repository. And they say, anytime the code changes, I'm going to go run every single test in the code. And if something stops working, it gets flagged, right? And someone is like, oh, we changed something and it broke. And then you can catch your things that break faster. You don't have to wait until someone else notices it in manual testing or your customer says, hey, why doesn't this work anymore? So by writing unit tests and getting code coverage across all of our classes, we're able to better make sure that when changes happen to our software down the road, if it changes in expected behavior, we know about it. Because we say, okay, I expect withdraw to act a certain way. I expect deposit to act a certain way. Right? And if it doesn't, all of a sudden the test will fail. So you don't even have to manually run the tests. Right? These continuous integration engines just watch your Git repository and say, every time something changes, run all the tests, run all the tests, run all the tests, run all the tests. It's fantastic. They're amazing tools. The next step beyond that is something called a continuous deployment. If you have continuous integration testing happening, and again, there's other levels of tests. This is just at the unit level. Your class does what it's supposed to do. There's bigger tests, integration tests, and system tests, and end-to-end tests, and all sorts of really cool stuff you can do in software engineering. But you can say, hey, if I make a change and all of my tests pass, automatically deploy my code. So if you're a company like Khan Academy and your product is a website, right, and everyone in the world accesses your website, you can say, okay, if I make a code change, automatically update my website. Done. Just happens like that, right? I go make a change, I fix something, I change some behavior, I add a new feature, whatever I'm doing here, and it goes and updates the website in real life. So their production website at Khan Academy updates multiple times a day. I've got a couple friends I used to work with who work there now. So they make their change in the code, all the tests run, if they pass, website gets updated. It's fantastic. So it lets you iterate and move faster, which is really cool, which tends to be a competitive advantage when it comes to businesses, right? You don't want to have to wait and schedule something with your customer and say, okay, I'm going to be down for this amount of time, and once a month I'm going to go do my updates and all sorts of nonsense. You got to be faster. So it's something that lets us get towards that if we have better testing here. Now, 100% code coverage is great. That's a great goal. In the real world, you don't always get there. It takes time to write the tests, and I'm always going to argue it's worth testing. Eventually, there's like really, really small edge cases, and if you're doing a good job, you're like checking all sorts of you can't give me bad inputs. If you have 7 different checks for, okay, if it's this bad input, don't do something. If it's this bad input, don't do something. If it's this bad input, don't do something. You're going to drive yourself crazy trying to test all of it. Not that it's a bad thing, but like you're ending up doing more work to test all the bad things instead of actually testing does it do the right thing. And it's good to make sure that if you do the bad thing, you don't get bad results, but you're going to drive yourself crazy. So you don't always get to 100% code coverage, especially around some of that validation stuff. But again, that's a good goal. A good goal. All right, so now we can talk about the project. I'm sorry, we're going to do unit testing in our project because we want to make sure that the code that we write does what we expect it to do, right? Let me go back to this here. There we go, this one here. This one? wrong spot here. I'm sorry. Let me come back. Okay, so we're going to build a class here. Find it. So we're going to write a class, create a class. We're going to call our class plane. So we're going to write a class for plane. So we're going to, we're pretending here, we're tasked with implementing the plane autopilot system. Right? We're not actually building out an entire autopilot system, but we want to write the class for plane that will eventually be able to run on autopilot. Okay, so plane has some attributes. Attributes of plane include the make, the model. Like planes have a number, n something or other. They always have numbers. I don't remember why, but those ones, you know, each plane will have its own. And then we're going to have a attribute for max altitude. Right? And anytime you have a value, you want to include what the unit is. Because if I just say max altitude and you say like 1 because you mean 1 mile, and my code is expecting it in feet or meters, it's going to be really upset if you put in 1 for 1 mile. Right? So we'll say max altitude in meters. Because the metric system is so much better. Forget our imperial system, it's awful. So the max altitude in meters, right? A landing gear, I don't know, we'll say is enabled, right, as a Boolean, right? So whether or not your landing gear is enabled or not, right, it should be true or false. True if the landing gear is ready and you're ready to land. False if it's not, right? So like the max altitude, right? Integers, these ones are strings. Here we got our landing gear enabled. And we have a, that's good for that. And we're gonna have methods for plane, right? We have get methods for everything. Now we don't need set methods for make, for model, for number. I don't even think you can change the number of a plane. We don't want to change the max altitude in meters. Like that should be fixed for this model of plane. It shouldn't change. We get methods for everything. We want a method for enable, disable landing gear. And for we want a change altitude method. So a couple things about these. So we're going to have a hard and fast rule on our autopilot that do not allow the plane to go below 1,000, or we'll say 100 meters if the landing gear is not enabled. So on this autopilot system, if someone says, hey, change altitude, like somewhere else in some code is going to tell the plane to start descending, we're not going to change the altitude if the landing gear is not enabled. Okay, so we need to check, hey, what is the status of our landing gear enabled? And don't go below 100 meters. Oh, yeah, we need current altitude, right? Current altitude in meters. There we go, current altitude, right? Where are we currently? Don't change your current altitude here, right? If our landing gear is not enabled. There's probably also something around speed. We don't really care about the speed. We're just pretending that, okay? And we're going to say do not allow the plane to go above 100 meters if the landing gear is enabled. Right? If you start going up too high and reaching too high a speed, the landing gear's on, you're going to break the landing gear. And if you break your landing gear, it's going to be really, really sad when you try and land. Right? So before you get high enough up into your ascent, you need to turn off the landing gear, right? Make it stow back up into the plane. Okay? So the method here for change altitude accepts a integer value for meters to change. Okay, so while we're changing our altitude, right, don't allow it to go above 100 if the landing gear is on. Don't allow it to go below 100 if it's off. So it'll have to get to 100 meters, then it'll have to turn on or off the landing gear, and then it can go up or down based on whatever we just did. Right, so like that 100 meters, like our stopping point. Stop here, don't go any lower. Right, if you want to descend, if you say, hey, I want to descend 10,000 meters, sure, let them go down to 100 and then stop. Okay, so allow it to change with change altitude, right, either positive or negative. We're going to go up or down, and then we're not going to allow, do not allow the plane to go above the max altitude. Max altitude. Right, so if I say, hey, I want to go up 10,000 meters and our max altitude is 5,000, just stop at 5,000, right? Set the current altitude to 5,000, right? Stop it there, right? So if I make a new plane and I say, okay, go fly, go up a bunch, stop at 100, turn off the landing gear, go up a bunch more, stop at the max. Don't let it go any higher. I can keep calling as many times as I want, right? So then we're going to return a true or false based on if it was successful or not, right? Not successful means, hey, if I asked to go down 10,000 meters and I stopped at 100 because I didn't have landing gear, I want false back, right? Tell me it was not successful. The thing you asked me to do didn't work, right? If I tried to go up and I had my landing gear on, no, false, was not successful. If I tried to go above the max, no, false, not successful. If I said, hey, just go up 10 meters, and then went up 10 meters, great, give me back true, successful. If I say go down 10 meters, great, go down 10 meters, successful. No problem. Does that make sense? It's like with our deposits or withdrawals, we said, hey, if you tried to do something bad, you get back false. This is what we're doing here with our plane, right? If it was no good, give me back a false, and I can test that, right? When I had my result for my test, I said, hey, try and withdraw, and it should be false if I try to withdraw too much. Or if it was supposed to work, I'm going to say, hey, it was true. Okay, so that's our plane class. We got attributes, and we're going to include a constructor. Include a constructor that accepts values for make, model, number, max altitude, in meters. So the is landing gear enabled and current altitude, we're going to give default values. We're going to assume when you make a new plane, it's on the ground, right? Your landing gear's on and you're at 0 feet. Again, forget sea level stuff. We'll pretend that doesn't exist because that gets really confusing, right? Because we're like not at sea level, so our altitude's not actually 0 right now. But again, sure, don't worry about it. So only take ones for these, right? And we don't have any sets. There's no set methods. We're not changing make, we're not changing model. You can enable or disable the landing gear, and you can either do this in 2 different methods or 1 method, either way you want. You can say, have a change landing gear, like enable true or enable false method, just a single one that takes a true false, or you can have a method enable landing gear that will just always try and turn it on, and a method disable landing gear that will just always try and turn it off. Okay? So these rules then should also apply to our enable and disable landing gear. So if you're above 100 meters, don't turn it on. If you're at 100 or less, yes. Right? For disabling, if you're 100 or less, don't disable. That's no good. Okay? So that's for change altitude here. Let's see. Method for enable, disable. So for enable, disable, don't disable if at 100 meters or more, and don't enable if at above 100. So wait, less than. So don't disable at less than 100 meters. Right, so at 100 you can turn on or turn off. Right, that's the one altitude you can turn landing gear on and off. That's our only rule for landing gear. If current altitude, right? Current altitude. If current altitude is current altitude. That makes sense for the class part, right? What we're writing a little plane class for. Right? And in addition to that, we're going to, nope, no, not the dots. Include unit tests for 100% code coverage. Right, we're going to write the unit tests to make sure that we wrote code to do something, make sure it does what it's supposed to do. Okay? What that means is I need the class and I need the test file. I don't care if you put anything in main or not. Right? It doesn't need to run when you click the run button. Nothing has to be in main. We're just writing the class and the tests for it. If you want to put something in main and test it the old-fashioned way of like, hey, let me make a new plane and call some methods on it, go for it. You don't have to not put anything there, but I don't care if you put something in it or not. Okay. So for 15 points for this, I can do that in just a second for you. Let me get this saved and I'll come back. I don't want to lose anything here. So we'll get points for doing it, and then we'll get points for testing it. We got 2 weeks on this one. Right? We're going to practice more. We'll do more classes, more tests next week as well when we talk about inheritance. Again, we're getting into the basics of inheritance. There's a lot to it. We're not going to get super duper deep because that's a core topic in the next course. But we need enough to understand what we're going to do when we start building our graphical user interface applications because they use inheritance. So we need to know enough to use it, and that's about it. Okay. So we add a rubric here for project 3. Project 3. There we go. So we'll go with complete and missing. We got 15 points here. That was sort of funny. That's okay. So we have plain class, constructor, accepts values, sets defaults for others. Right? It was supposed to accept that list. I can't copy. It's not long enough for me to copy everything in, but like the list that I was supposed to take, make, model, number, max altitude, take those, and the default, the landing gear and current altitude. So you don't need to accept landing gear status and current altitude. Just put the plane on the ground when you make a new plane. Okay. The plane class, private attributes with public get methods. So if you have all of your attributes listed as private and they all have public methods, 2 more points. Okay. And then the plane class enable disable landing gear method. 2 points for that one. The plane class change altitude. The change altitude method, 2 more points for that one. Right, so that's the plane class. The attributes and the methods. Then we're going to get points for tests. So test. We're going to test the plane constructor. All values, including the defaults are set. So we're going to make a plane and say, okay, if I make the plane, here's what I expect the values to be for make, for model, for number, for max altitude, and for landing gear status, and for current altitude, and assert that they all match. Right? So a brand new plane should be what we give it. Constructor, I spelled that wrong. 2 points for the constructor test. We're going to test the plane enable disable landing gear methods. And then our test plane change altitude method. That puts us at 14. Okay, 14 is okay. We'll do 14 instead of 15. So I think that covers everything. Right, our constructor, public attributes, public gets, enable disable, change altitude, and then testing all of it. That's overall score thing. So we'll say 14 points. Okay. Again, it's a lot. It's new. It's a brand new thing we're doing with classes. It's going to take a little practice. Start cracking at it. We'll have more time next week. I'm not going to spend 3 hours talking. I'm sorry if this went so long. Next week will definitely be a little shorter. We'll have time to work on it too as well next week. Right. Other questions, thoughts, concerns? I was not watching chat. I'm sorry, chat, if you're there. Okay, no one said anything. We're good. That's all we got. All right, cool. If you're online, take care. I'll be around hanging out in class. If you ping me on Discord or send me a message or something. I'll see you at my phone. We can go from there.